Okay, welcome everyone. We are about to start. I'm Diego Kaminger, Deputy Chief Standards Implementation Officer for HL7, working with Dan Breman and Viet Nguyen, our Chief Standards Implementation Officer and Chief Standard Development Officer. And welcome back to the second day of this event on synthetic data. So yesterday we had around 80 participants, 70, and we learned a lot about the status and limitations of synthetic data generation and use, about how to ensure fairness of synthetic data and evaluate fairness of synthetic data, and how is the industry using synthetic data and academia for education and testing. Today we have 4 panel sessions. The strategies for transformation to and from FHIR, and how to use FHIR for quality, FHIR synthetic data for quality measures, synthetic data or any big FHIR data, scale and performance, along with the Health Samurai and great participants from Microsoft and Google. Definitions about commercial offerings, what is going on in the industry, what are they offering and how it works. And finally, a panel on synthetic data for machine learning and artificial intelligence. Our ask for you during this session is try to participate. We want you to dialogue with our participants and speakers. It's not usual to have all these brains talking about this subject, so do leverage it. You can submit your questions using the questions and answer feature in Zoom. You can use the chat to add comments or feedback, and you can wait until our speaker finishes, and we will take time at the end for questions, so you can raise your hand and we can call you to speak. And please keep your video off while we are in session and you're not speaking, so we can all see the current speaker. So if everything is okay, I will introduce our first speaker for our first panel. The first panel is a trove of synthetic data, but no FHIR access, how you can transform information and use it for quality measures or whatever you are doing with synthetic data. We have 2 speakers, Michael Riley from the Georgia Institute of Technology and Eric Pan from Stanford. Michael is a research scientist in the Georgia Tech Research Institute for Emerging Healthcare Technologies Division. He has a master's in computer engineering, and he is an early adopter of FHIR, facilitates the development of clinical quality measures for public health registries, and also integration and interoperability projects in public health. So, Michael, if you want to share your screen and begin your presentation, you are on.
Thank you, Diego. We can share screen. In the beginning. Thank you for introducing me. Welcome to the synthetic data event. A trope of FHIR data, but no way to access, I think is the name of the panel. My discussion today is about using synthetic data in quality metric-driven applications. Diego said, my name is Michael Riley. I'm a research scientist at the Georgia Tech Research Institute. This is a sister institute to the Georgia Tech family. We do most of the corporate and government outreach and work there. We're about 1,500 people big. We have an emerging health division I'm a part of. And we've been an early adopter of FHIR in this space. We've been fortunate to see the modernization of health technology and be a leader in that space. And so what I want to talk about today is some of the work we've done in our application space, how synthetic data has improved that quality of the application, and what we do in the lifespan and tools we use for doing so. So like I said, we've been mostly developing modernization efforts around FHIR and other technologies related to FHIR, other HL7 initiatives as well. We're mostly focusing on FHIR-enabled registries, so health registries that need to retrieve medical information out of an EHR system or any other type of FHIR-enabled system. With IG guides, we're looking more into that sort of space. We're also interested in standardization of FHIR as an extendable platform. And we also have a whole natural language processing engine as well that we use against different medical notes. We try and hook up to various EHR endpoints. We're also very strident about adhering to the ONC and USCDI standards in our application. So we strive very hard to keep on that standards path. So most of our applications look something like this. This is a really simplified framework and definition for talking about it. But basically what we'll have is healthcare providers will provide a data store, usually in FHIR in some form. And we need to retrieve that data, perform some analysis, and submit that enhanced medical data over to usually a registry in public health. It could also be a user client using the application directly. It could be a few different other use cases, but mostly registry data. And so the analytics framework has to do the job of retrieving the data from the data store, know it retrieved it correctly, do the analysis on the data, and make sure that it fits into the registry form correctly, and then do the mapping and submission over. And what we use to help describe this operation for the framework is an open clinical standard definition, either through ELM or CQL. We want to use those already existing clinical standards. And if they don't exist, we work with a subject matter expert to create them in an open clinical standard like CQL. So we try and, this is what I mean by quality metric driven application. We try and use the quality definition to help describe the context in which we're going to retrieve the data from the data store. Next slide, please. So in our life cycle of clinical standards, we sort of, I've sort of made a narrow slice here about how a clinical standard is sort of developed and created for our workflow. So of course, there's the data store. If we have access to a data store, we'll of course perform the preliminary analysis on the terminologies, the context, the criteria. If we do not, we need to work with a subject matter expert directly and come up with these criteria and terminologies later. And there'll be a process of analysis where we write out by freehand a plain text definition. And then an engineer will work through and build the correct CQL script, the correct ELM definition for testing. And then we will add it to the application, build it into a workflow for the analytics, and then we'll be testing and operationalizing from that. So we build from the definition, and then we work with a SME to ensure its correctness. And then we need to then verify it in the application, which is of course where synthetic data can help with this. In most cases, we don't have access to directly through the data store. We have access to simplified data, or we'll have access to a synthetic data set already, or we'll have to regenerate a lot of records for this purpose as well. So synthetic data itself can be used as a helpful validity of clinical definitions in a FHIR environment, especially the EHR FHIR environment where we can standardize the retrieval. So what are the reasons we're doing this for? The obvious one is preventing risk from private data. We can ensure that we generate data effectively and correctly, but we don't have to touch any PHII information while we're doing this work. So this gets us a faster development cycle. We don't have to worry so much about EHR access. So long as we have simulated data for this, we can move quickly. And our groups may be about 10 or 15 developers large. And if they all have to sign off on agreements, it takes a longer time in the project work cycle to complete that. So having a platform that can work in a synthetic sandbox environment means we can build content much quicker, means we don't have to worry about the particulars of any EHR environment. We can work from that. The other clear benefits are reiteration of specific criteria within that synthetic generation context. So we're going to talk into this more, but we can build generation to the test to ensure we're, as another way of verifying that we're collecting the context we into. So this is another way of checking our work and making sure that we're doing the definitions as we need to, as if we can't generate synthetic data with the right scenario, where there's an issue there. So if there's a discrepancy there, that's another validity check before we've even gone into testing. And then, of course, the most probably clinically relevant one is when you have rare disease scenarios or specific interactions that are difficult to find in the wild. You can actually use simulated data, of course, to make a large set of that data, make the variety you need, and then test your application against those rare scenarios. So your synthetic data allows for you to quickly and easily make those specific definitions, so long as they're known and you can simulate them. So mostly, we do quite a lot of custom modeling for our synthetic data generation. We mostly do it in Fire. So we build to the definition. We have specific targeted interactions we're looking for, where there's specific use cases we're checking for. We'll have specific model scripts to do specific things, and they're highly configurable for our needs. And then, of course, it's Fire generation prone. So anything you're generating with Fire, we tend to put them back into the data store as either a Fire document or a direct Fire resource. Sometimes we'll write directly to an underlying data set, but mostly we try and keep it in Fire, as that's a more common language for people to review. But that's also, of course, in the generation, there's interpretation and error at the Fire level for that stuff. And of course, because it's a custom model, we're making bespoke generation logic. We're haggling between different models we're making to make sure that they're consistent between each other. So with a custom model, you have to make sure that you dot your own I's and cross your own T's, so to say. Of course, what a lot of this talk has been about, and a lot of the panel time has been about Cynthia. We're also moving into and using some Cynthia. Built from clinical research. Most models are clearly referenced, which I like a lot. There's a highly modular design. You make Cynthia modules, you don't make custom models, which I appreciate quite a lot. It's easy to verify a module correct, and you know it's going to integrate perfectly in the cohort generation. So you can do large scale population. When I say large scale, I mean tens of thousands or hundreds of thousands. We're not doing millions of records. We're mostly in the medium tier size of cohort definitions at GTRI. But we've found Cynthia to be pretty effective at tens or hundreds of thousands of records for generation. And it does it quickly, effectively in Fire, and then we've been able to import those records into a data store and use them as such. It's difficult, though. I think a criticism I have of Cynthia is it's difficult to simulate interactions across the existing modules without getting into more of the complex details, such as a Cynthia attribute. So a good example may be smoking as a risk behavior. Smoking, there's already a smoking module within Cynthia. You need to use the correct flag attribute that Cynthia defines for the patient is smoking in order to interact with the smoking module. So you don't want to redefine those types of risk behaviors, but if you want to incorporate them into your custom module, you have to do a fair amount of work to understand the dependency there. The other thing I really like about it is Cynthia is data-driven. It's a declarative JSON language, very easily reviewable. It's got great tooling, especially the module viewer for doing such things. So it's much easier to review than some of the other clinical definitions we've worked with. So a little bit more on the custom modeling. We basically do what's called a discrete event simulation. We make some simple characteristics around a patient parameters definition. And then we have event generator cadences per domain, where every once in a while the patient will go to some sort of visit, maybe a chance they go to some visit. This goes on to a virtual stack that describes an event timeline for that patient. And then this stack this queue is dequeued over time. And then each of these events will either generate another virtual event or will generate a Fire resource. So using this simple model, we can get some state-dependent resolution. So we can have a diagnosis that only occurs after a visit at a certain time, right? So we'll go into a visit context. And then this sort of lets us do an entire patient quickly and easily, and then we can review the various cadences that were used to generate that patient. So we have some custom logging around that. So if we need to check on how this patient was generated, if we're generating the specific rare interactions we need, that's fairly easy to do within your own custom modeling. It's also terminology dependent, of course. So when we're generating these records, we need to have terminologies up front. We can't, when we eventually resolve the fire, you must have them defined correctly. And also a nice little convenient feature, this is a non-EHR context that's allowed. So if you need to just define medical devices, if you need to define supplemental information, if you need to just define a model library or a measure or anything like that, you can use a similar custom modeling situation for that. So we can do other fire types out of the clinical domain as well with custom modeling. So I just took a screenshot of Cynthia here. As a modular definition of disease states, I think it does a really great job of tracking the patient life cycle. I think it's fairly easy to follow along with, and incorporating new modules is very, very simple. There's already Cynthia also already has a fairly large amount of common modules for reuse. We found them to be somewhat useful in our definitions, so that's been helpful. Trackable cohort definitions over the lifespan of a patient is also a super helpful component to Cynthia. We get fire generation for free. We didn't have to remake the wheel on that. It was provided through the Cynthia modeling. We just use the definitions of Cynthia nodes themselves, and we'll get the relevant fire information. But as far as I can tell, maybe I'm wrong about this. It only does EHR only context. So anything supplemental, anything around billing or anything around not out of the direct patient medical care, I don't think it does. I might be wrong about that, but we've only been able to find it to use in an EHR only context. So that's a limitation we sometimes run into, and we have to resort to custom modeling when working with Cynthia. And so here's sort of where our data pipeline comes together. We'll either define an ECQM, a CQL file, or what we call an NLPQL file, which is our version of a CQL file for natural language, like document review, basically. We'll make from those, we'll define these models first, these clinical definitions. We'll make the model, either a custom model or a Cynthia model. And then for the custom model, we'll generally put things into a Firebase, which is a document store of fire resources. It's really easy to work with for the most part. I recommend using that as a data store for when you don't know what you need in a fire context. And for Cynthia modules, we found that the definitions we needed fit into the OMOP on fire context already. So we would write directly to OMOP on fire with the resources generated from Cynthia. Custom model can also work with OMOP on fire if needed to. You just have less limiting options in a Firebase system. You just drop the fire resource, it's there. You don't have to worry about veracity or terminologies in the Firebase server. So either of these can feed our app, since of course both of these data stores are fire enabled, and so our app is fire enabled. We use the same retrieval context for retrieving for both of them. But it's nice to have different data stores, and we know which data store can work with which model, and we know which model we use to make which definition. So that's sort of the general definition here. I'm going to leave it open to questions here. I will say we found synthetic data to be effective for simple proof of concepts. We found it to be effective for initial testing of clinical applications. And we found it mostly effective at our sanity as well, to make sure that we're meeting our customer needs and our sponsor needs. Our sponsors enjoy it as well as a moment of SME input. They can work with a clinical context, and we can make synthetic definitions that meet to the needs that research shows, which they're appropriate for. So that's the end of my presentation. I'm going to leave it open to comments here for a few minutes. Checking for chat.
Thank you very much.
Thank you.
We have if there are no questions.
Yeah, I have a question. Yeah, maybe not question, but
you have a question.
Yeah.
Okay.
Thank you, Mike.
Go ahead.
Yeah, I appreciate you use Firebase, and so I would love to invite you into SQL on Fire track, which we started we restarted it like half years ago, and this is as well about analytics and using the proof tools like relational and columnar databases. I think it could be interesting for you. So please look in Zulip in Analytics on Fire. So it's a very nice community. Best engineers like Josh Mandel, I don't know, Google guys, Hells Murray.
Right. Yeah, absolutely. We've been abreast of the community for a little bit here. I think we need to be engaged for sure. Thank you, Nikolai.
There is a question from the Q&A. It's when you say definition, are you talking about a complete, consistent synthetic record?
When I'm talking about a clinical definition, I'm talking about a quality metric definition like a clinical quality language script or an ECQM definition. So I mean a clinical definition as this is a patient and it's part of this cohort definition, or it's excluded from this definition for this reason. That's what I mean by a clinical definition. Is this patient fall under the cohort category? Is this patient matching for the specific cohort? So with the models, I just call them modules or models. So anything about synthetic generation, I've been referring to as models. Anything about the specific clinical context being used, we put that into the definition. We call it a clinical definition.
Jason is telling us that Cynthia has support for claims in a few formats of varying quality, but that support is not on by default. There are some hurdles with licensing of certain billing terminologies, and X12 is not supported at the moment.
Yeah, so the good news for our work, Jason, is that we don't have so much need for X12. We just need to have FHIR representation, since we're only mostly working with the FHIR.
But you are talking about claims or anything else that you wanted to represent?
Most also medical devices, also imaging support and things like that. So it depends on the specific project. This has been just a small thing that's come up once in a while when determining if to use Cynthia.
Okay. So I think we will, if there's no more questions in the room, I will move for our next presentation, our next speaker, and then I will ask some questions to both of you, if you are okay.
Thank you, Diego.
Perfect. So let's introduce our next speaker, Eric Pan. Eric is an MS student in biomedical data science at Stanford University. He previously worked as a software engineer at Canvas Medical, OneUp Health, and Epic. You are old, a lot of jobs. When focusing on interoperability projects and FHIR API design and data transforms. He has a BS in bioengineering, minor in bioinformatics from UCLA, where he explored the intersection of healthcare and entrepreneurship and designed and taught a seminar on student entrepreneurship. He has an MS in computer science from Georgia Tech, where he currently teaches Intro to Health Informatics, which focuses on health IT standards and FHIR-enabled projects. Welcome, Eric. The floor is yours. Please, your presentation, and then we will ask you questions.
Cool. Thank you, Diego. Thank you, Michael. Sweet. So, assuming everyone can see, I'm gonna start the slideshow. Yeah. So the thanks for having me here. So the panel of the talk is, Trova synthetic data, and what I'm going to talk more about is once you get that synthetic data, how can we convert it to and from FHIR? If we want to interop with downstream applications, that sort of thing. So one of the ideas I want to introduce is there's a style of programming called functional programming. It's nothing crazy. I go through the basics that can maybe make mappings more consistent and hopefully help everyone have a good time. So I'm going to talk a bit about the motivation, quick definition of functional programming from my lens, and then go through an example of mapping FHIR to OMOP, something that I've had to do a couple of times, and then next step suggestions, that sort of thing. All right, so about me, Diego had a good introduction, but I'm a current master's student in biomedical data science. Very early in looking into my own idea in terms of how do we sync data across healthcare. So open suggestions, and previously worked at different health tech startups. And first job was at Epic. Yeah, so the motivation for this talk, again, it's a lot of as we know, as implementers, there's a lot of nuances in actually getting the data into the right form and enabling these things, right? We can line everything up, but how do we actually get kind of the nitty-gritty work? So we need these data mappings for interoperability, making sure apps can plug and play. And it's tricky because this is fundamentally a backend problem. So usually people just relearn and start from scratch. There are also many ways to approach it, many nuances, subtle errors come up. So And really, like I've had to deal with this a lot. I've been at kind of each step of the pipeline. It's really a communication problem. We have this abstract idea of how to organize information in one sense. There are a lot of stakeholders. All these stakeholders, need to say, and not everyone knows everything, right? Because it's hard, and it's so people need to be involved, and everyone comes from different lens. So kind of on the left here, and I've been on this side too. It's like, oh, you might be more of the project manager, like the organizer. It's like, okay, how do we like map these standards? You read the two specs. It might be your first time, as it was for me, and you're just going back and forth. And it's like, okay, maybe I'll put everything in a spreadsheet, and then you hand that off to the dev, and it's like, okay, great. It's like we have this spreadsheet, we have this, but there's a lot of back and forth, and the dev does the best job. Writes a bunch of code. I've been there too. It's hard to get right on the first time. No one really does. And then after that, you have all this code, and now we got to actually get in the real world. And now it's like, okay, well, did it match, right? And a lot of things get lost in translation. So then you have a lot of meetings. You gotta talk a lot, make sure everyone's taken care for. So fundamentally, the challenge is there's a syntactic challenge. So it's just like when you have data, is it organized in the right way? It's more like the programming structure. You have the systemic challenges, like when you actually run the thing, what kind of errors do you come up against? Like what kind of edge cases do you need to handle? And then there's the semantic one. I think that's ultimately where people want to get to, right? It's just like when we represent clinical information in one form, can we get it other? And fundamentally, in mappings, like the small nitty gritty things, it's just like you gotta like update, modify fields, ignore, add, remove data, and then also deal with optionality, which can be tricky. So how could functional programming help? Well, functional programming, it's like a style of programming. And the goal of it is to make behavior like more like math. So the whole idea is, in programs, you can do a lot of things. And you can define functions, right? But in math, like a function is a very specific term. It's basically you take an input and you get an output. And that sounds like regular functions, but in computer programming, computers are very flexible. That's good for us, but it can also have some foot guns in terms of like, okay, sometimes you get an input, but then a lot of things change about the outside world, right? And in math, when you get an input, all is input, output, nothing else changes in the world. Like that function does that one thing. Programming where we can do a lot of things. So functional programming is how can we move closer to math? There's this idea of pure functions. So I put pure in quotes. This is sometimes debated a bit, but the whole idea of a pure function is there aren't side effects. It's like, again, you don't mutate external state. A simple example of this is sometimes you might write a function and it might rely on like a database call. Like if you're looking up terms or you make an API call, that makes a function not a pure function because you need to rely on like the external world. It's not just inputs, outputs. And pure functions like aren't inherently better or for certain use cases, right? It's not like, oh, it's pure and it runs better for everything, but in some cases it does. And so it's, it's just, and the main idea is in data transforms, we really think of data transforms more like math. It's just like we want like this thing in the start and we just want something at the end and we want nothing else to change in the middle. So and there are other functional patterns too. I don't really talk about it here. So for this talk, it's going to be like semi-interactive. So I know it's early for people, but for this example, I'm going to take an example of going from FHIR. As we all know, it's document-based standard. I think of it as like just NoSQL, and then converting it to OMOP, where OMOP's tabular, more designed for different use cases, more population health. They all have like similar properties. Like both of them could have optional fields, but as you all know in FHIR, like you can have like nested list of objects, nested objects, those sort of things. In OMOP, because it's a table, like each row has like singular values. The way kind of vocabularies are handled differently. So in FHIR, you have different concept sets, you have value sets. You can kind of flexibly reference thing. And in OMOP, the Odyssey like did something that's also smart. It's just like you handle it all in one go. You have like one central place to look. That's kind of the Athena kind of concept ID sets, and then someone maintains that well. There's also linking, that sort of thing. So looking at the docs, this is again, and everyone's coding FHIR journey. This is where it starts. It's not the easiest to start out with. There are definitely some nuances to work with. For example, like, patient, interesting enough, like most of the fields, I think all of them are like technically optional besides research type. And it's interesting too. It's like what's required depends on the use case. Like for OMOP, because it's more designed for population health, like things like race and ethnicity are required to be OMOP compliant, because that type of stuff is important for understanding, broader populations things. So for this example, I'm just going to cherry pick some fields. So you're going to look at the name, identifier, gender, and then go back and forth between these standards. So I took the spec and I just wrote it out in a different way. Then in Fire, race ethnicity is handled through extensions, which can be added generically. So these are extension definitions. And then, as mentioned, Odyssey maintains this Athena database for concept IDs, those sort of things. So this example, and this is tricky to interpret. First time, like there's this concept of male, multiple things pop up, but I think this is also in the spec. It's like, okay, you should use this concept code specifically. Cool, nice. And then so this is going to be the base example. So again, like Fire is like document based. So this is one example of a Fire resource. I just made this up. And then we're going to convert it to this like OMOP person row. So if you notice here, like I've also represented this as a JSON, but in OMOP, we could just think of it as like, okay, you can represent a row in a database as a JSON object. So this is just kind of like a one-to-one thing. So if you notice too, some of the properties I said before, like Fire, they're just, you can have multiple things in a field, right? Identifier, you can have multiple, they're nested objects. When you're dealing with a tabular database, it's just like, one flat row. Of course, there are benefits, drawbacks to both. Sweet. And then the assumptions we'll make is, we're only expecting kind of the previous fields outlined. The OMOP concept IDs, like, that work is done beforehand. So we can keep our functions pure and just say like, okay, we've defined this set beforehand, so we don't need to do any external calls. And then string formatting is consistent. So it's not like, oh, you need to check for like spaces, those sort of things, just to keep it simple. So this thing on the left is just like, let's say, okay, we've identified this concept ID goes to this string in Fire, and assume we have these maps when we work on them. Sweet. So we can make this as interactive as people want. I know taking new people are muted, but I will keep an eye on the chat. Okay, so this first example, again, we're taking the left and we want to apply some sort of function and then get something on the right. So this is kind of a first attempt, right? It's like, all right, this makes sense. Why don't we just take each thing in the Fire resource and we'll just specify as we go. Okay, so this is actually like, probably solves most of your things, but is there anything maybe wrong with, and this is actually, I'll say this is actually might be the hardest nuance in the talk. It's just like, all right, is there anything that might be wrong with this? And it's very subtle, the first one. And I'm gonna wait like, if someone wants to answer, then go for it. If not, I'll wait like 10 seconds and then. And I'll say this too, I've been staring at this code much longer, so I have an unfair advantage. Okay, this is a very subtle thing. It's like, okay, what about the data types? And if you notice here, let's see, the person ID, this is super subtle. The person ID here is an integer, and in Fire, the value for the identifier needs to be a string. So this is the type of things that come up for mappings, like, that developers just need to deal with. So this is the fix, right? You just like literally update this field. You say like, okay, I'll cast this to a string. And then now like when I pass this integer in, it will come out as a string. Otherwise it would show up as a number. Cool. I see a raised hand. Any question, comment, or I think we're, if not, all right, I'll keep going. And then all right, so this is kind of the V2. Structurally very similar. And honestly, so this is an interesting thought. You might be done in this case. It depends on your use case. And what I mean by done is, so if you have synthetic data and you have a guarantee on like what shows up already, then you say, okay, I can guarantee that all these things will be here when I perform the mapping. I don't need to handle an edge case. Then you might be good. But what about if you don't have that guarantee? What if you're dealing with like, live production data, or you're hosting this as an API, people are making external calls? Like, what if you can't say, oh, I'll absolutely have all the fields? And, per the OMOP spec, some of these fields are optional. So if you look here, like Fire spec, like, all these fields are optional. OMOP spec, there's a required field, and the ones that are optional are these ones. So technically in OMOP, you could not have a birthday time for a person, and that's still a valid OMOP. And you don't need the birthday for Fire object either. So it'd be nice if we could account for that in our mappings. And again, it depends on your use case. So now we take this example, and we don't have the birthday time anymore. And the change to this is, okay, instead of doing a direct index, and this is Python, by the way, so I guess I'm biased towards my language. Instead of doing a direct index for the input dictionary, we do a .get. And the difference in Python is if you do a .get and the key isn't there, so if I try to look for this birthday time key and it's not there, if you do this bracket syntax and index directly, it will throw an error if it's not there and just crash your program. Sometimes that's better. If you do .get, instead of crashing, it will return a none. So it'll let you keep going. So in this case, we'll do a .get, and I'll fix that. Great. And yeah, again, like this will fit most use cases. But what if you host this as an API, right? And what if something's just missing? Something's just like, all right, we tried our best to be OMOP compliant, but like things happen, right? We still want this thing to run, or like for our workflow or use case, we don't actually need this data, so it's not super relevant. How do we handle that? And that's where code starts to get really messy. So for this example, I've omitted the let's see, I've taken out one of the required fields. I think is it was ethnicity constant ID right here. So what happens if we took this code and ran that? Well, when we index to ethnicity constant ID, we would have gotten an error if it's missing. And also, what happens? Well, you might think, why don't we just do a .get, right? Would that solve it? That also wouldn't solve it, because then we would have an extension with a null value saying we have an ethnicity, but actually has nothing, right? And that could lead to other more insidious errors. So like subtle things like that. And then the safest way to handle that is you just do a bunch of ifs. So I just went ahead and did the ifs for all the cases. So basically now we went from this, which like, if you could look at this, it's like, oh, it kind of looks similar to the Fire resource. And now we have this, we gotta check all cases. This solves all of it. And I think we're done. It's okay, this is how we handled all the cases. Shameless plug, I worked on a library at Canvas called Pydian. It's still very early, and I'm hoping to work on it more eventually. But the whole motivation is, can we apply ideas from functional programming and remove a lot of the boilerplate code, a lot of the ifs checks? And the whole mindset is, instead of if something succeeds, then we'll chain a bunch of operations to it. If it fails, then we'll turn none, and we'll assume we'll do something like the .get. We'll assume we don't want to crash. Okay, so this is the example. We took kind of the last code, and then if you rewrite in Pydian, basically the idea is you can get the similar structure. I will say too, you don't need to use Pydian. If you use ideas from functional programming, you can rewrite it in a structure like this. So the nice thing is you get the properties of like, oh, this looks like the Fire resource, and we're mapping to Fire. And that's kind of nice. And then when you have these meetings with stakeholders, everyone involved, this could be the central discussion point. And hopefully, something on the right is a lot easier to discuss about than something on the left. Like if the birthday field goes wrong, instead of digging through this, you could just say like, okay, everything's self-contained here. So that's OMOP to Fire. So now let's go the other way, to Fire to OMOP. So Fire to OMOP, you deal with like different kinds of problems, and it's mainly like, okay, now instead of your input being flat, and you want something nested, you start with something like that could have a lot of these nested cases, and you want it to be flat. So how do you deal with that? The simplest solution is you just make some assumptions and you just index into directly. So for example, I could assume that the first ethnicity extension will always have the race extension. So then if I make that assumption, then I could dig into that. And again, like sometimes that you can totally do that if you have full control of the data. So again, you need to check for types. So then, all right, here, these are all strings, cast these to int to be OMOP compliant, because people make assumptions based off the standards, which makes sense. And then cool. And then so that could solve some cases, but again, what if you're dealing with like live data or other things? Then you would want to handle the optional fields. So how do we do that? So then you could do that by adding if statement. So in this case, this one looks nicer because in OMOP, like the main optional field is just like the year, date of birth. So in Fire, we could just say like, okay, if this is missing, then instead of doing this direct index over here, we can do like this .get and then handle this case, and then include it if it's there. Okay, great. But another key assumption we made was like, okay, we assumed like the first extension would always be the thing in this. I guess I assumed in this example. So how do we handle that? And that's where, okay, now the code blows up a bit more, right? Because it's like, okay, for every list, we want to make sure we're looking for the right thing. That's good. You should do that. And that's what we added here. So again, we started these two, should do the same thing. And this looks a lot more intimidating, right? And I don't think it's anyone's fault, because the code actually is really simple. It's just like you go through this extension array, you loop through each one, you check this single field, like whether it's whether it's equal to this, whether the system is this URL or this URL. And then if you find that, you assign the value, and then you get that. But you start with this point. Even me, like I wrote this and I'm looking at this and it's like, oh, I need to like think pretty hard early in the morning. It's like, what did this do? And what it's doing is not crazy or anything. So the motivation is like, okay, if we had like a framework or used functional programming ideas of like, can we condense this? Can we think in terms of like stuff everything in a functional transform? And know that it's a pure function, then we can, not worry about like, oh, what's this library doing? Then hopefully we can condense it, again, rewrite it to a shorter form. So this is how I implemented in Python. Under the hood, I did not do this fancy syntax logic. It uses a library called JamesPath, which is pretty big. There are also other approaches to indexing and digging into nesting data. There's a library called Glom, and there's like a library called Benedict. So a lot of other options. But the whole idea is like, okay, we can hopefully identify some pure transforms, and then we can stuff as much into a single line, and then the discussions get easier. Cool. And then one idea I'm looking more into is like, okay, what if we had a framework in terms of thinking like operations you can chain, that sort of stuff? Then instead of writing these, kind of one-off functions, maybe there's a starting point. And then it's kind of like a mapping standard in a sense, assuming it's useful. Great. So that was a lot of talking. Some closing thoughts. Consider functional programming patterns. I didn't talk about a ton, but I think the main idea is like you get some nice properties for like data transformations by using pure transforms, because it kind of reduces the class of errors when you're debugging. You'll focus more on the logic rather than, oh, like the terminology server was down and that's why this didn't work. So if you can and you still need to do those terminology calls. So if you could organize your code to say like, okay, I'll do the call first, and then when I start the actual mapping part, I have like this pure state, because if the call failed, then it'll fail at an earlier step. Hopefully I could save some time. And the other thing too is you want to keep your code simple. So like for some of these examples, I'm biased. I came from the API side, and when I was writing this talk, I was like, oh, I need to handle all the cases. But sometimes something like this might be enough, right? It's like you might not need a fancy framework. If the inputs has some certain constraints, then you should take advantage of that. And then lastly, like is very much in lieu of that, just consider use case in the goal of the mappings. Is this going to be a core infrastructural piece in which you might want to handle more of those cases? Or is it just like you need to run this one off, see if it works, you're kind of tinkering, then yeah, there's nothing wrong with going fast. Just be careful if you're doing this live in production. And then think through like how many cases you need to handle, and can you make simplifying assumptions? Because again, I think our goal is to really enable a lot of the downstream applications, make sure stakeholders are able to effectively provide their input and kind of embed that into the systems we built, and also minimize the amount of meetings that we don't necessarily Okay, and that's it. So thanks for listening. What's next for me? I'm working on my master's part-time. I'm working on the startup idea. It's called So Medical right now, full-time, very early. So we'll see how that goes. Yeah, feel free to reach out, and thanks for listening. So and if people have questions or comments too, we could.
Thank you very much. Eric, there is a question in the questions and answer boxes. How do you deal with patient IDs? In OMOP, IDs must be numerical, and in FHIR, IDs can be text or UUID or something like that.
Yeah, that's a great question. I had to deal with this problem this summer working at as a research assistant for healthcare. The naive answer to start, and this might be just work, is like maintain like a dictionary mapping one ID from another. So for my use case, I had to write a script to say like, oh, like we need to convert to OMOP to like run this ML model. And we have FHIR data. So, and you know, the assumption is you download your FHIR payload securely somewhere, you run the script, and then you spit it out. So the idea is like, okay, we essentially just need to keep a record of which idea went where. So you could just say like each time I run the script, I'll generate a dictionary and assume like, okay, I could start from like ID 1, ID 2, etc. And then if you start with that assumption, then it's like, okay, if you want to make sure you have, you know, your IDs are consistent, then make sure everything before the script is run. And then another approach could be too is I'm not an expert at this. I think I pulled from Stack Overflow for one implementation. There's a way to say like you can encode a string as an integer. So you can say like, oh, if I have a, you know, int ABC123, you can write a function that says like, okay, a function that maps ABC123 into some number, like some numeric value. That's reversible too. So then you can use that as a way to encode it. The problem with that is if you have long IDs, which a lot of UIDs are, then you will get very long integers. And sometimes that might not even fit into a Postgres database. Like it might be like, oh, like U32 or something, which means like 32 bits. And sometimes your ints like get longer than that. But yeah, that's another possible approach.
Okay, so we have some minutes for more questions. If there are no questions in the questions and answer, oh, there's another. Oh, Andy Richardson, how are you managing semantic equivalence and potential information loss as you confirm an FP module?
Yeah, that's a great question. I don't right now. I think everyone wants to minimize information loss, and it's a hard problem. And there aren't really the tools to measure that. So right now, I don't think there's anything yet. I think if people have ways of approaching this, like by all means, like bring it up, and love to hear it too. My thinking is if we could, maybe as a starting point, if we could fix almost like standardized like mappings between versions. Like if I'm going from like, I don't know, FireR4 to OMOP, you know, 5.3 specifically, and start there, then we can say like, okay, we fix.
Yeah, you also have the advantage that you may also have some profiles applied to the FHIR resources. So if you know that your information is in US core valid, you have something to leverage there, but you may not. So it's so you may be.
Exactly, that's a great point too, and maybe just a shorter way of saying what I want to say. It's like have some sort of baseline, right? And I don't think there is a standard baseline yet. So like having like the implementation guides for different profiles could be a great starting point to say like, hey, what does it mean that we have a lower quality mapping? Well, if we know what we're going from or we have a baseline what that is, then it's easier to find.
I think I saw some work that applied some rules to your resulting FHIR data and will evaluate if something was missing in your results. But I'm not sure where I saw it. I will try to share with you. Nikolai is asking us, do you open source your work?
A great question. Like the Python right now is open source. I really pitched for Canvas to open source it. Also, I pitched too. There's a framework one of my old colleagues at Canvas worked on called Firestarter. So I will find the repos and post it there. And I'm hoping to open source my work too. So we shall see. Yeah, but they definitely don't. It's tricky because I think the ethos of it is great, and if I want to push for it, you always want to avoid like I don't know, the like you want to nurture the spirit of the community, and then you want to avoid corporate greed. So you might be controversial, but you might have something like the Elasticsearch fork that AWS did, where it's like, oh, they just like took the entire repo and made their own service. I mean, it makes sense, and they're entitled to do that. But it was interesting too, like that actually makes it harder for users because then Elastic like went on 2 different licenses. We were actually using an old a version of Elasticsearch at Canvas, and that created a problem because we couldn't upgrade legally, right? Because they switched the license because AWS did the fork. So, but short answer is yes, I hope to.
Hey, I'm asking
there are
because
no
I'm
more-
looking. Sorry, because I'm looking the place when I can talk with you because we are working in this area more than 10 years. So I did some academic research with the lenses and huge math, how it can be converted back and forth. I even did presentation in Dev Days about these approaches, and I would love to discuss it more deeply.
Yeah.
As well, functional programmers. Yeah.
Definitely love it. Yeah, I'll reach out.
Okay, so if you will not have any more questions, I will ask my questions to both Michael and Eric. So my first question is to Eric. Have you evaluated the fire mapping language during your journey?
Yes, I have, and there are a lot of nice properties to it. I think it handles a lot of the semantics of Fire better, and it is a functional mapping in a sense. So that is really nice. The I got stuck in Python land, and I think a lot of the tooling is in the Java ecosystem, which is good there. So I think there's a lot of opportunities for synergy, and that could be like one approach to standardize. So I'm hoping to dig into it more though, because to be honest, I haven't dug too deep yet.
Good. My second question is for both of you. What were your big challenges when mapping from and to Fire? If you have to state your biggest challenges were mapping, some feature of Fire or some type of structure that was your biggest problem when mapping.
Yeah, so I'll go ahead and go first. So also work on the OMOP mapping for Fire, OMOP on Fire. Most of the mapping stuff I need to worry about are mostly about terminologies, making sure terminologies, if they're defined in a non-standard way, have a clean definition to be exported in either a LOINC or a SNOMED or an RxORM code. So being able to work with terminology services and make sure you've got the best standardized code for your resource based on what's created is probably the biggest challenge to make a more standardized resource for people to use. So the specifics of the mapping, at least specifically for OMOP, are not super complicated, or fairly direct and easy to figure out. And the Fire language doesn't have much complication to the definition itself. But the main problem is terminology. You've got to get the terminology and the right concepts for others to be usable.
Eric, your take on this?
Yeah, no, I agree with Michael. Like the terminology is tricky too, because ideally you want to like bundle everything together so a user wouldn't necessarily need to go to Athena and like download something. But there's also like licensing issues with like redistributing entire vocabulary sets, as you all know. So and there's work to get around that. I think maybe to start, if we standardize the mapping layer with like things like OMOP on Fire and some like open mapping work, then we could like that's something that could be freely shared and then go from there. Another thing too might be like getting clinical domain expert help. I think like if you're within a single organization, I think it's fairly accessible. Though I think that's a cool day about communities like this HL7 one that brings everyone together. I feel like for most developers starting out, what I saw when teaching new students at Georgia Tech too is just like it's a lot to dig into first. So it's great to have a open, welcoming community.
Okay, my next question is, how do you validate your work? How do you know that what you did is okay? What is your scope of testing? What do you usually do?
Yeah, I can start with this one. It's tricky. I think it's definitely you want to ideally have a set of unit tests, so you handle like the type of cases you want to come up. So maybe as an example, if you know you don't need to handle optional data, you don't need to write a test for that. But if you do, it'd be good to maybe say like, oh, I have 3 cases where, birth date is random, and then next case is the name is, not there, etc. And then you've handled the class of like optional data, that sort of thing.
Your take, Michael?
Yeah, so I think the problem here with validation is it's difficult to do population validation with the Fire interface itself. So there's no easy way to do that without using some sort of measure you've already defined. And if your job is my job, which is to confirm the measure is accurate, that's not very helpful, right? So a lot of the things we do are direct database queries. We will do sandbox instances. We'll have de-identified data pulled from real data sources that we can confirm first and work through that as well. So we'll do real integration testing as our validity testing. But there is a gap here for metric validation. You can't really use the Fire interface to do that, or at least no easy way to do so without making a million calls or using Fire in a way it's not appropriate for, right? So that's kind of, I think, an interesting, probably not going to be a feature of the Fire.
And I think we have a time for last questions. What do you think are your next steps? The next steps for our community on this subject? What do you want to see in the future?
Yeah, so for my work, I'd like to see more tighter integration between metric definitions and synthetic generation. I think one can inform the other and vice versa. So I'd like to see those two communities do some more cross-pollination here. As it seems like we need to go from clinical definitions to a synthetic data source. And so why can't we spend more time worrying about what those original definitions are and make sure those can be clearly derived into a synthetic data source?
Eric?
Yeah, definitely stay friendly, and also as use cases come up, I think it's good to service them up. I'd love to hear them too. I'm thinking more about working independently on the framework and seeing if there are more use cases. But right now, it's a very academic problem.
Good. Thank you very much for your presentations. I enjoy very much your problems. I like problems. So nice to see how you work. And see you next time. And see you around.
Thank you for having us, Diego.
Yeah, thank you for hosting, Diego.
Okay, our next panel, I will introduce you our next panel. It's managing big synthetic data. And we will have Farhana Bandukwala from...
Yeah. Guys, can you see my presentation?
Yes.
Okay.
Yes.
Yeah, I will have a short talk about like vendors' perspective on synthetic data, a little bit about me. So in my past life, I'm PhD in radiochemistry. I worked in positron emission tomography. Then I switched to programming and working in health IT. I don't know, more than 15 years. So I'm a passionate member of Fire community. I contributed into FirePass, like pushed it at the first version of FirePass. Then we implemented open source Firebase, and now I'm driving the SQL on Fire in V1, and now we have a V2 versions with other members. So, and my daily work, I'm CTO of Health Samurai, and we are crafting like Fire++ platform for next generation healthcare applications for our bright future. Okay, and to be honest, from the vendor point of view, we need synthetic data for testing to be sure that quality of our Fire servers, our Fire tooling is good. So we want to do like functional tests, and for that we need good fixtures But at the same time, we need a lot of flexibility to try to cover all the edge cases. As well, we want to test performance, and here very important the fast generation of data sets. And in a complex configuration for customers, we definitely want staging area which has like production-like data, but with no security risk. And that's exactly what Farhan tried to address with the Google team. So congrats. Just a little bit, some illustrations. So let's say you want to test like fire search, rev includes, filters, and stuff like this. And to do it properly, you have to generate very specific data set. And with some noise, to cover the edge cases, corner cases. And I really wonder that Cynthia switched to DSL. I looked into the source code when it was just JRuby or something like this. And so it would be nice to have a DSL to very shortly describe what specific data set I need for these tests, and then generate it. Another idea, so we are not Google, so we could not write our own generators, but eventually maybe. So to use profiles and other IGs to don't repeat yourself. So if we know that this data should be of this with this profile, so we can take a lot of information from profile without writing it down. Okay, so about compliance tests, yeah, so that's tightly coupled stuff, like, because in the tests you see that we are building data platforms, so we are testing data and access to the data. So for me, it's two very interrelated problems. Ideally, for compliance test, I would love that test would be authored by somebody else, not by us, by committees, government, I don't know, open source. But sadly, the existing ecosystem is quite superficial. So, and we still have to invest a lot of resources into internal deep tests, and that's what a lot of people doing. I think we can organize and do it together and then reuse by others. Yeah, and again, I explained why it's related to synthetic data. And there's a very nice approach, which is called generative testing. And I rarely hear this topic in the fire community, so just to bring it to the page. Yeah, because you may write tests for specific cases, but you're never sure that you cover everything. And there's a nice approach when you can write generators and formulate some properties instead of simple assertions like this patient will be detected by this query. But you can formulate some properties and then run potentially all possible combinations and be sure that your system is working. So we did a couple of times like generative testing, found very funny errors. That's okay. Yeah, for if we're talking about like big data and performance testing, so what we need to test it, yeah, we really need the like realistic a lot of realistic distributed data. And then we want to test it to be close to the real productions. But if your generator is slow, so then things kind of minutes turning into hours and sometimes days. And eventually engineers give up on doing these tests. And that's sad. And that's why I think it would be nice to have a very fast generator, which can generate data at the speed of the loading. Yeah, generate data at the speed of the loading. There's some problems with the parallel generation. In Cynthia, it would be nice to solve them. Because if you want to generate huge amount of data, yes, we want to use some cluster and run it in a parallel. And ideally for us, I don't know how to do this, but generate data right in database, like database guys usually doing, because you're not moving data that can be like 1 or 2 order magnitudes faster, just generating in database. Probably the answer is have a DSL and different engines, which potentially may generate C or Rust code for quickly generating at the speed of the load, or maybe transpile it into some SQL stuff and extensions to just generate in a database. Yeah, another problem that when you go deeper and your customers loading the data, they need some staging areas to play with this data around the, I don't know, different tests, smoking tests and other stuff. And we definitely want to have to quickly build these staging areas without any security risk of information leaking. So ideally, we may have some tool. This is exactly what Farhana told, which is analyzing data and then generate very similar data with the same statistical properties. Yes, and probably it may use generators from the previous slide. So then it looks like very nice connected solution. Yeah, so my summary, yes, we're using it for testing. We need some open source expressive generator DSL to write less. We need performant engines for that DSL, and we need some tool which can learn from existing data and generate for us like production-like data without any risk. And for compliance tests, it would be nice if somebody will write it for us. And I think the critical point is going to be the fixtures and these tests and all this stuff. So that's everything from my side. Thank you. I'm ready for your questions.
Thank you very much. I see no questions in the chat yet. I will ask you one first question is, what's your definition of deep? What is a deep test for you?
It's quite pragmatic, yes. So again, you may run like official tests. You may run the test written by Mitre, and after that you should go and cover a lot of edge cases and write your own tests. So we open to share our experience with these groups, so they can cover these edge cases for us, because usually it's quite trivial tests for compliance. They don't go deeper, than don't challenge your system with enough complex situations like parameters, I don't know, some combinations and stuff like this. Yeah, broken data. I understand it's hard to author, but if guys from Mitre or other guys want to do this, we open to share our experience, and we really don't want to write this test by ourselves, or we can even open source what we have and start from there.
Okay, any other questions for the Samurai? He didn't say the features will be really important. He said the fixtures will be really important. The fixtures is what you create before testing to know that everything that it needs to be in place before the test is in place.
Yeah. So that's terminology from
that's testing terminology. Fixture is what is
not data set, but the fixtures. Yes,
it has to be set before the test to ensure that the test will run correctly if the code runs correctly, like the preconditions for the test.
Yep.
Any other question? We will move forward with our next speaker. Thank you very much, Samurai. Our next speaker is Jared Erwin. He's a software engineer at Microsoft involved in developing the Azure Fire service. He has over 15 years of software development experience in the healthcare domain, with experience ranging from embedded medical devices to population health. He also holds a PhD in biomedical and health informatics from the University of Washington, where he now teaches as a lecturer in the same department. Welcome, Jared. Thank you for being here with us, and the floor is yours.
Thank you, Diego. Hopefully you can see the slides, if I can get them up to presenter. Does that look good for everyone?
We are seeing the, now we are seeing the slides, yes.
Okay, good. Yep, thanks for the introduction, Diego. That's just a little bit about me. And thank you to Nikolai and Farhana. Those were great presentations. I was just going to talk a little bit, maybe at a practical level, what we're doing to generate, pull in data, and how it's working for us. So on Microsoft's Fire servers, right now solution to try to pull it in is we pull in ND-JSON files that similar to things that get produced by the export operation from the Fire spec, right? The flat files that get a little faster than just doing regular puts and posts. So I really like Nikolai's thought about generating the data and shoving it directly into the database. This is still somewhat of a slow operation, I would say, for large data, right? When we're talking about terabytes of data, this is still taking hours, and it is a problem, I think, that we are still working on and need to address, but it is what we have right now, so it's what we're using. And then what do we do to get these ND-JSON files, and how do we produce them and make them available easily? I think that's what I'll talk a little bit about now. So I also wanted to think a little bit about what does everybody consider big? Like when we talk about managing big data, how big is big? And from our point of view, I think it comes down to these different scenarios. We've talked a lot about generating data based on existing samples and then making it match statistically. I think that the size of big also matters for the different scenarios that we're using. If you have, you want to model a set of data for a moderately sized hospital, or you want to do kind of a life sciences scenario, or you want to do payer scenarios. So we have different sizes that these different users would have in their Fire services, right? So I think 1 terabyte for some individuals would be considered too small. For other users, it might be really big. And on the flip side, you might need to go to 100 terabytes to really be considered big for many users, right? Or even bigger. And for Hannah mentioned, we go beyond big to massive or huge, or whatever we want to call it, right? It can get a lot bigger than that. So how then do we have these tools or generators? Right now, the generation is still not fast enough for us to be able to generate, say, 100 terabytes on the fly to load in quickly. So we have sets of resources sitting out there, right? We have pre-generated, and then oftentimes it needs to be post-processed to have the proper properties and batches of different sizes, so that if we want a 1 terabyte or a 10 terabyte, we can kind of go out and grab enough batches to meet the data size that we need and then start loading those in parallel. But yeah, super fast generators that could generate this much data quickly, so we don't have to have static data. As Nikolai said, that would be awesome. We're not there yet, though. So I kind of mentioned this a little bit, different kind of resources. These are the different ones that we've been thinking about right now. We have payer personas, a very different resource mix. Maybe you have a lot of explanation of benefits. Those individual resources are a lot larger than, say, person resources or patient resources. So you get a data size, target data size, say 10 terabytes, you're going to have a very different number of resources. And so then you have these different variations, and that's where we target our batches of resources that are sitting out there in these ND-JSON files, right? We pick these different batches to match these different personas, and then you can pull them up and load them into your Fire service. And they should be clinically relevant, each batch kind of isolated and coherent within itself, and not stomping on the other sets. And then you can just run this and create your test service or test instance that will be relevant for whatever you need it to do, right? Whether that's just performance testing or scale testing or ML operations. So eventually at some point, that's still too slow. As I said, it can take hours to load in these if you've got multiple terabytes. So we do then stash preloaded databases for the highly used ones that you can just kind of copy and stand up in a few minutes. That's kind of our final solution to that, to get really efficient and quick tests going. And that's kind of where we are for that. I know that's really brief. That was really just what I wanted to cover, kind of what we're doing to manage our large sets of data at Microsoft right now. So I'm happy to take some questions from
I will tell you some questions from the chat. L. James is asking.
Yeah, so now I'm off mute. I can go. The question I have is on your personas. Do you have urban versus suburban versus rural? Do you have diverse support personas that would be needed for the industry's work on health equity, or any internationalization that HL7 would normally deal with for some of the outside of the United States members of HL7? Thanks for your response.
Yeah, it's a great question. Not right now. I think we will continue to grow our library and our design of the different personas, but I don't think we have that level of detail yet.
Okay, let's get our panel together again so we can ask some questions to all of you, and maybe you can answer, some of you can you stay. Okay, Crystal, you want to give them a break of 5 minutes?
Yeah, yes, let's take a 10-minute break. We'll try to report back here at 10 minutes to the top of the hour and make sure all of our next set of panelists are ready to go.
Perfect.
Thank you, everyone.
Thank you.
All righty. Well, welcome back, everyone. For those who weren't here yesterday and didn't meet me, I'm Dr. Viet Nguyen. I'm the Chief Standards Implementation Officer for HL7 International, and helping to moderate the next session we have. This has been a really awesome set of sessions and discussions, and we hope that you're all enjoying and learning around the content. We appreciate the engagement in the Q&A and the chat, and I think that makes for a great event where we hope you're able to provide your feedback and identify areas where we can have conversation, and of course we want you to all think about what are potentially the next steps that HL7 and others in the industry can help to advance this work, because I think this is just the beginning of at least our journey around synthetic data. So we wanted to move along, and I wanted to introduce our next session, which is commercial synthetic data. Is it coming? And I know that not everyone in the industry kind of recognizes the importance and value of having good synthetic and test data, but I think our next two presenters will kind of help us to understand what's happening and their offerings to the industry around the use of synthetic data. So we look forward to the presentations as well as the discussion following. So again, if you have questions along the way, please feel free to put them in the Q&A, or if you have comments, put them in the chat. We're trying to do our best to monitor them and contribute to that conversation as well. So first up, I'd like to introduce Dr. Chris Hazard. Chris, so feel free to come on screen. He's the co-founder and CTO of DivePlane, organization founded in 2007, focused on decision support, visualization, and simulation of hard strategy problems for large organizations, including federal agencies. He has a PhD in computer science, and with a focus on artificial intelligence, especially around the notions of trust and reputation. So he's a software architect of the CDMA infrastructure at Motorola, worked on robotics and logistics for Kiva Systems, now part of Amazon Robotics, and has also been an advisor to NATO on cybersecurity. So I really like that he's bringing this non-healthcare perspective to this conversation, because I think we have a lot to learn from others in the industry. So he's also has worked on game design and done research in AI/ML. He has a long resume, so I've highlighted a few things. So Chris, we'll hand it over to you. We look forward to hearing more about DivePlane and your approach to synthetic data. Thank you.
Thanks for the introduction. I just like to think of myself as an applied mathematician. So today I'll be talking about the state of the art of commercial synthetic data. And my short summary is, it's here. It is ethical, it is good, we can do it. And I'm going to try to convince you why it is. A lot of people have talked about what synthetic data is here at this conference. So I'd like to step back and ask a bigger question about why are we using it? What does it really do? One way to think about, what are we trying to achieve? We're trying to understand relationships within systems, and synthetic data is part of the answer if you think about the data as the model, right? So you've collected a bunch of things, there's relationships in there, that itself is its own model. Synthetic data allows us to condition and shape that. So a way to think about synthetic data, instead of just saying, oh, it meets our privacy needs, is it's data you don't have, but you wish you had. There's data around it. Maybe the data meets your model performance needs, but it doesn't meet your privacy needs. That's the basic case. But what about, we talked about before, conditioning, fairness, bias. What if you know something is rising and you want to condition the data to take advantage of the knowledge that this thing is spreading, that something is changing fundamentally in some group? And then also the debuggable aspect of it. If you train a model on the data, many models are not very debuggable. What is it really doing? We can talk about that more a little bit later, but with synthetic data, you can see it. If there's outliers, or there's anomalies, there's interesting patterns, you can slice and dice it every which way and understand it deeper than you can some more opaque model. And we've also talked in this conference about the ML and data-driven approaches versus simulation versus handmade and combinations. And we're a firm believer that use the right tool for the right job. There are cases where it makes sense to use a simulation because you have a lot of that crystallized knowledge of relationships, so build that out. But sometimes you don't always know those relationships and you want to express them in different environments. And that's where the data-driven and machine learning approaches come into play. Now, another step back I like to take is, why should I care about privacy when I don't care about privacy? There's a lot of people who feel like, well, we need to check the box so that we're HIPAA compliant, whatever compliance happens to apply to your industry, but it's deeper than that. It's all about incentives. That's why privacy matters. The only thing that is truly private is, the computer that is the piece of wood that is my desk. That's the only perfectly private thing. But where, as some others have discussed, where do we draw that curve? I like to think about it with incentives. Let's take a lesson from COVID, early 2020, when universities first started going back to school. They had to have tests for the students to see, do you have COVID? But students, they didn't really want to take the test, because students, think about an 18, 20-year-old says, I'm better at taking care of myself and I can judge my own health better than the school, because there's an incentive here where the school will, put you, basically quarantine you for a while for all the right reasons, but they would feel ostracized and left out of their, all the engagements that they think a mask should be sufficient for. So the fact that the schools were offering these COVID tests, which is great, I think the right thing to do, but that data collection on the other end made it a perverse incentive so that students would go off campus, get the test, and then make their own decisions. So we need to be thoughtful about how these incentives play with all different forms of data collection and how we use it. Another one, a really clear one, is from Progressive Insurance. I can use them as a slight punching bag here, but it's actually widespread. Those USB sticks you put in your car, and you can modulate your insurance premium based on how well you drive. And if you drive well, oh, great, your premiums go down. The problem is, this made them a lot of money. It's been doing great in the industry. You can get a better insight to your customers and the overall landscape. But you can find people posting on Reddit, oh, I had to retrain my driving behavior around this. Oh, and I don't hard brake anymore, because that is the single thing that increases your premium the most. So if you hard brake, drive an extra 30 miles around town, extra greenhouse emissions, extra time, extra wear and tear in your car, but that'll offset it. Or, do I hit the child on the road or let it register a hard brake? If we have these perverse incentives, what are we incentivizing? In healthcare, are we incentivizing people to hold back things because they know it might be used in ways that they don't like? And it's really difficult to measure these sorts of things with these incentive systems. And we see that in reproducibility in science all the time. If we're thoughtful about privacy at the beginning, we can do more things right. Now, differential privacy, we've talked about it a few times. Let me just sort of give a blanket idea of what that is for those of you who are less familiar. That says that we're using mathematical mechanisms that make sure that there is only an infinitesimal probability that any individual affected the statistical results. So if I leave you and all of your medical data out, I should get the same result for any one individual person, but I can glean the insights. So a lot of very powerful mathematical mechanisms around here. But if you tell somebody, oh, hey, we just published your synthetic data for research purposes, don't worry, it's differentially private, you're going to get a lot of people who are angry and upset and don't understand it, because it is a fairly heady topic. What people really want, or what they think they want, is something we're calling ex post differential privacy. Think about this. Imagine you watched a movie and at the end there's all the credits and you say, hey, look, that person had my name and maybe they look just a little bit like me. It's really rare, but it can happen. Well, if you are concerned that maybe your data was published in some way, that could be grounds for lawsuit. You can sue anybody about anything. But now think about being on the other side of that. You're in front of a jury saying, look, we use these complicated differential privacy mechanisms, which are really, really good, but this other person's claiming that they were actually published in the data or something similar. Maybe it was just like them, but a slightly different first name and that weighs 5 pounds less or something, but something close enough. What is close enough? There's an expectation of ex post differential privacy. That sounds like a hard problem. If you look at the social security numbers that are used, the Social Security Administration says about 55% of those digits or those numbers are exhausted. So if you do nothing other than generate a 9-digit integer, put the letters SSN : in front of it and put it out there, you could be at risk for publishing sensitive data. And this is some legal interpretations in some jurisdictions and similar identifiers. So how do we take care of this? How do we make sure that we are both actually adding the right types of privacy and the right types of privacy mechanisms, but giving the assurance that we are on the other end? Another thing, all fields are potentially sensitive. I know there's all the nomenclature about PII, PHI, quasi-identifiers, there's a whole zoo of terms around that. Anything could potentially be sensitive. If someone in my family had an injury at 2 a.m. and we happened to be the only people in the hospital in the emergency room at 3 in the morning. I walk across the street to a 7-Eleven. I swipe my credit card. If that data is somehow relinked in some way, that can be traced back to me. So every additional piece of auxiliary data, especially with all the data streams out there, make everything potentially sensitive. So we need to think about it that way. Privacy attacks are numerous. Even though this is a very dated paper and there's many other mechanisms out there right now, I like this one because a lot of people still think about the mechanisms used here, but there's many different ways to try to remove and re-identify or get significant information about an individual, try to predict them. This is another reason why even things like T-closis and L-diversity, which are considered outdated, a lot of the privacy nomenclature, the idea is being that you make sure you add noise everywhere, even in the very homogeneous areas of the data. The reason why this is still important is you want to make sure there's plausible deniability for everybody everywhere. Okay, this sounds like a really hard problem. How do we solve it? How do we solve all of these different notions and aspects of privacy simultaneously? Well, it's actually a little easier than you think. So here's a really small toy example where it's a 4-dimensional data set. You've got color, height, X and Y, and size of the circle. As you can see, none of these really line up. And you couldn't say, well, look, I see the circle in this one and this one, but you can still infer a lot of really good stuff out of this and get really good results. So why is this? I want to give people an intuition for why synthetic data works and how it can be private. Let's say we've got this data set, 1 through 5, 6, 7, 8, 9, 10. We apply, basic linear regression on this, bam, we get a straight line. Great. We can represent the same idea by just having 5 points at 1 and 5 points at 10, if we only care about linear regression. That's very rare that we would actually do that. And even just sampling and reducing the chances that we collect data or use it in the synthetic data, if we use robust bootstrapping, we reduce the probability of disclosure by quite a bit, and we get more statistically reliable results or more representative results. If we want to communicate the idea of a circle, let's go up a little dimension here. You can see the original data here, a handful of points, and representative data, none of those match up. Whatever the cones of uncertainty around all of these, we can still communicate the idea of a circle. Sure, maybe it's a 10-sided polyhedron, but it's a circle, basically. We can infer quite a bit. Intuitively, let's look at a cool mathematical problem called the kissing spheres problem. So we got 4 spheres here, blue, 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 blue. Those are the data points. The centers are the actual data points, and that's the uncertainty around there. So I could, you can publish my blood pressure, but it's got to be, at least this far away, or my income or address got to be this far away. That only leaves us with these 2 dimensions, a little tiny area to create synthetic data. And if I put data in there, I know that there's 4 people represented there. So I don't have much privacy. Well, let's go up another dimension. The radius of, notice that the size of this box is 4 on a side, and the radius of that center one is square root of 2 minus 1. If I go up to 3 dimensions, square root of 3 minus 1. What does it do in higher dimensions? Now, if you look at 9 dimensions, that inner circle, that inner sphere, hypersphere, is the same size as the box. If that doesn't make any sense to you, congratulations, you're human. And as you can see, if we go up to 64 dimensions, it gets even more space. Basically, it's very easy to take advantage of the curse of dimensionality and give results that are very dissimilar, but give good results. Here's an example of my company's C-suite. We had on the laptop not connected to the internet, we put in all of this data for the C-suite. We ran it through our software, turnkey, did nothing else to it, had everyone look at it, make sure they were comfortable sending it off the machine, had our CIO remove the data appropriately. You can take screenshots of this, publish it anywhere. You can get a tiny little bit of information about what our C-suite looks like, but you can't find me anywhere in there. And I'm comfortable sharing this with the world. Looking at utility, so privacy and conditioning aside, the synthetic data utility almost always by itself will be less than or equal to the original data utility. There's some rare exceptions, but in general, think about there's a little loss there. But it's like sampling or grabbing another sample of the data. But if you can condition it, if you can add that knowledge, if you say, well, we want more anomalies, we want more something, we want to fix some fairness and bias issues, that's how you can really get more utility out of it. You should measure the utility in every which way, not just your target feature. Try to predict every single feature in the data. Try to look at all the statistics, look at the privacy, make sure everything's far enough away. The synthetic data is very strong for structured data today in the market. We can do all of these things and give you reports so you can rest assured that I'm safe, my data is safe. We actually judge our software by the worst possible outcome, the closest thing in the original data to the synthetic data, so that you can rest assured that it is private. The language and images, there are still some privacy concerns. The first publication applying differential privacy effectively to language, I believe, was about a year ago. And so that's still a little bit new, a little bit nascent. The industry is moving in that direction. We got to be careful about those sorts of things. And lastly, I like to think about it in two ways. There's the generalized data and the specialized data. Generalized data is we're looking for big trends. We're looking for where things are moving using scalable, data-hungry models. So like, for example, the sesame seed allergy, for those of you who are less familiar, in 2021, the FDA said we need to understand where sesame seeds are put in food because these allergies are going up. Most of the fast food companies said, well, we're just going to put sesame seed, a little bit of powder in everything because it's too much liability to put it in one thing. So all of a sudden, sesame seed allergies are rising rapidly. This is the sort of thing that big data, that data lakes, synthetic data lakes are good for, but you always have to watch out for Simpson's paradox and spurious correlations and data dredging. Small data, if you have, like, let's say you're performing some sort of clinical research, a novel medical device or a drug, this is where small data efficient models can work very well. Where it is just taking your data, synthesizing it so you can share it, and share it outside your organization and really see, did you get the statistical validity that you wanted without the pollution from the general data, which might be dampening it down a little bit. And there's our presentation.
All right, Chris, thank you so much. Well, we're going to hold off on questions until the end. So I'd like to invite Noah Zamstein to come join us. Thank you, Noah. So Noah is with MD Clone. She's a senior data scientist. She has a PhD in computational chemistry from the Weizmann Institute of Science. She gained some experience as a data scientist and a project team leader before joining MD Clone in 2017. She works on the algorithmic and application sides of the synthetic data engine and applying statistical and data science methodologies to MD Clone's core business. I'm glad we have these data science professionals, both as presenters and the audience, because I know I'm learning a lot, and some of the statistics part is going over my head. Well, I appreciate you all being able to help us understand the data science roles. So I'm going to hand it over here to Noah to share, and we look forward to the discussion following her presentation.
Thank you so much. Let me know if you can see my screen.
We can see your screen, and we can see you in presentation mode.
Okay, great. So I'll be talking about diving into synthetic data lake, which is MD Clone's data lake. And just maybe to recite some of the things that have already been said many times in the past 24 hours. So in order for us to train machine learning models, we need large amounts of data with relevant content. So for example, if our aim is to improve treatment in certain diseases, we need data which is contemporary and relevant to those diseases. But unfortunately, clinical data is siloed due to privacy restrictions, and the access is often limited to just the treating clinicians. So we need a way to harness the data while being first and foremost committed to patient privacy. MD Clone is a software company and our software is used to conduct self-service research. Our platform is called the ADAMS platform, which stands for Ask, Discover, Act, Measure, and Share. And it all starts with the ask. Now, the flow is that clinical data is stored in a customer warehouse. The data is not MD Clones, it's the customers. And a copy of it is being loaded into an MD Clone data lake instant that allows users to access data via a query portal, which we call the Ask module. Now, the Ask module is organized such that any user, and we were being asked many times about which professionals can use the different platforms, and the answer here is that every professional, every healthcare professional who wants to know things about their patients, or even patients from different departments can use the platform to ask any question about their patients. And it starts with defining a cohort and specifically defining a reference event, which is a time zero event. Like, for example, the first time a patient was diagnosed with diabetes, and you can ask questions around that reference time. Now, the user who either have access to original data if they've acquired an IRB, or doesn't have access to original data yet, can query original data behind the firewall of the institution such that he or she is sequestered from the data, but they're still querying original data. And then after acquiring the cohort and the different variables of interest on that cohort, can obtain a synthetic derivative of the cohort and then do the analysis. I'm going to talk about a different solution that MDClone has recently developed, which is synthesize and then ask. In other words, synthesizing parts of a data lake and then allowing many different users to ask many different questions. Now, how do we approach this problem? Because as I mentioned earlier, our problem is retaining the privacy of patients. And you'll note that categorical and date data are more identifying than numerical data. And Latanya Sweeney has already proven about 20 years ago that 87% of Americans can uniquely be identified using the zip code, sex, and date. And this may be surprising because sex is usually just a 50-50. It's a categorical variable with a very small number of categories. Zip code seems to be the most problematic here because zip codes can go down to maybe 20,000 individuals. And date is also, and remember, she used the birth date of William Weld, who was the governor of Massachusetts, in addition to his zip code and sex. So date and categorical variables are the usual suspects, and they're being treated very differently to numerical data because for two reasons. First, numerical data is much more difficult to acquire. So if we're talking about what kind of data might be available to an intruder, we're usually talking about things that are categorical and dates. And numerical variables are, since they're continuous, they're much more difficult to really pinpoint. So who can know my last A1C very exactly, unless I told them exactly what this was. Another approach that is very central to our longitudinal synthetic data generation is the fact that we're taking a sample of a population. And this is a very strong privacy protection means because you reduce the probability of knowing whether someone is even expected to be in the data set. So I want to give an example of a quite simplified use case that we did for testing out this solution. And we used a cohort of hospitalized patients with a series of creatinine measurements. And an acute kidney injury can occur, especially for hospitalized patients, which is a transitory episode of kidney failure that is usually reversible, but can also result in longer-term kidney damage. And we created a synthetic data lake from these patients, and we compared the synthetic data to samples from the original data. And acute kidney injury was identified by one of the KDIGO criteria. And for the clinicians amongst you, you know that usually in order to very accurately define acute kidney injury, you need both creatinine measurements and urine output, which is usually not that very well documented. So I actually used ChatGPT here. I know that this might be small, but I kind of toyed around with whether ChatGPT can identify acute kidney injury without me prompting it with the KDIGO criteria. And surprisingly enough, when I uploaded the synthetic file, without telling it whether it was the synthetic or original samples, I bound them together, and I didn't tell it which was the synthetic and which was the original, and was able to, it knew what the KDIGO criteria were, and it even suggested to me how to determine whether the acute kidney injury was resolved. And so what I want to show here is some results from this use case. First of all, each row here stands for one sample from the original data, and the last row is the synthetic data. And I'm showing different profiles of patients where blue stands for acute kidney injury was resolved, while red was not resolved. And the dotted black line, I hope you can see it, marks the beginning of the AKI event during the admission. So you can see, for example, for this patient, their creatinine was kind of stable around 1.4, and then there was a jump in the creatinine that applied to the KDIGO criteria, and so it was identified as acute kidney injury. And here I'm showing different plots of the results from the 5 original samples versus the synthetic data. And you'll note that you can't really see a difference between the original and the synthetic data. So if I didn't tell you that this was the synthetic sample, you wouldn't be able to tell it apart from the other original data, the data samples. These are the readmission rates among patients with and without AKI, and you can see that if the patient had an AKI event, they were more likely to be readmitted. This shows the admission length of stay for patients receiving or not receiving ACE inhibitors. So if they were receiving ACE inhibitors, their length of stay was longer, probably indicating that they were hypertensive. And here I'm showing the ROC curve for mortality prediction, and the different lines stand for the different samples, where the synthetic data is one of those samples, but I bet you can't really tell them apart. So in conclusion, the use of synthetic data can increase the availability of high quality and patient level data sets. Now, it's true that we're a commercial company, so our product is not widely available. Our business model is such that we install our software on the customer side, and we are working in a model of a yearly renewal of this contract. So we can't really open source this. But our hope is that one day synthetic data would be acceptable as non-human subject data, so that those large data sets could be released without the concerns of privacy. And hopefully this will promote research and increase the availability of such data sets. And I'm happy to chat after this with whoever wants to hear more about us. Thank you so much for listening.
Thank you so much, Noah. Thank you. Chris is joining us. Great. You are. So again, we invite the audience to enter your questions in the Q&A. I'll keep an eye on those as well as in the chat. But just to kind of start out the conversation, you know, the Cynthia tool has been discussed in multiple sessions yesterday and today. And for those who are unfamiliar or who didn't attend some of yesterday's sessions. Cynthia is a tool developed by the MITRE Corporation to develop synthetic data represented as FHIR and CDA data based on models that they have created and have actually encouraged the community to build out additional models. So those are very kind of structured, predictable kind of data. How do you see each of your organizations and your offerings can complement or fill in the gaps on the use of Cynthia? So we'll kind of go in the order we presented. So Chris and then Noah, please.
Yeah, I think it's an absolute yes and. There's some areas where Cynthia is fantastic, and there's some areas where it's at the edge of knowledge. We might not know the models or the mechanisms yet. So using data there to fill it in, I think is very powerful. Having a synthetic data tool that can condition and say, we generated this data from Cynthia because it meets all our needs, but we need these extra columns, we need this extra information that we can only get from this other data, blend those. And that's how you can use modern synthetic data tools in ways to fill that in ways that are viable, accurate, and ethical.
Yes. And Noah?
I think Cynthia is a great tool, and especially for COVID, where data was really absent, at least in the beginning of the pandemic. MDClone has a very different philosophy because we're sitting, our platform is sitting at the source data, so that when we synthesize data, we don't make any assumptions about the distributions of the data, including, and this is a flip side, because if the data is missing for some reason or miscoded, then this would reflect in the quality of the synthetic data that we're creating. So I think there are pros and cons to each of those solutions, and they certainly can complement each other.
Great, thank you. So there are a number of like recurring themes in each of these sessions over the course of the last day and a half or so. And so one of them has been around privacy. Certainly, Chris, you addressed it a bit, but along with de-identification, re-identification of this data, can you each kind of elaborate how your company's approach, you presented a little bit, but how you address these and how you can, mitigate some of these concerns potentially with, this group as well as with your customers?
So I talked about it a little bit, but everything is privacy first. If we can't pick up on exactly what that is, we replace it with a random 64-bit number. Everything is that way, unless you tell it, this is a law of physics. This is a thing that we know that there's no privacy here. As I mentioned before, we use all those mechanisms that I talked about, everything from differentially private mechanisms all throughout. We think about it as a cross shredder. By the way, I didn't mention we do not use neural networks. We do not use black box techniques. We use non-parametric techniques. So we know the data that was used to synthesize every record and use a keep away. We understand we actually crack the nut on a probability space or surprisal spaced kernel so that we can keep things far and away and keep those ex post differential private mechanisms as well. After we synthesize the data, our software does all of this, but we have a validator, as we call it, which looks at every way you could reasonably ask to analyze it, from model performance, everything from recall, precision, accuracy, Spearman's rank correlation, all those sorts of things, statistical similarity, and privacy measures in terms of how far away is that data, and roll all that up. And we grade ourselves by the worst case so that we can build that trust for all of our users.
Great, thank you. And Noah, I think I'll ask you to kind of combine, because that was going to be my next question around the privacy and data identification, as well as the concept that's been recurring around validation and how your customers can be sure that the data is representative of what they need.
So obviously privacy and utility have to be mitigated, but I'll answer the privacy part first. So MDClone does a lot to protect privacy, and we do it already at the source. So for example, one of the first things we do is hash IDs, because IDs aren't necessary for research, and our aim is to enable research. One of the other things we do, and I mentioned the problem of dates, is that we hash dates, we shift dates along the patient's timeline, such that the time between events is retained, but the exact dates are not. So if something happened to someone on a very specific date, there's no way to know that unless you have IRB and a special requirement to go back and obtain the original date. And this is done even before synthesis synthesization. And synthesization itself does things to the data that protect it from privacy concerns. And just of note, we have been validated by third parties. And this is one of the things that we make sure to do periodically in order to verify that we are on the right track for that. In terms of utility, we provide a comparison report for each data set generated so that the user can compare side by side the original data to the synthetic data, and obviously without seeing outliers or things like that that would expose the original data itself.
Great, thank you. So we've learned over the course of the event that we have a really diverse audience. We have researchers, we have clinicians, we have data scientists, developers, payers, and of course, you know, from our perspective, HL7, we have standards developers as well. So how do you see that these other organizations might be able to utilize your data beyond what you say your existing customer base, or maybe you can describe, you know, some of those kind of customers. Chris?
We take the approach that, well, it's twofold. One is that data scientists who know who know the tools, who know the techniques, they can get the most value out of our software. We're an API first company, but sometimes you just want it to work, right? You have the data in, maybe it's just in a spreadsheet, maybe it's in a file format, something you got, and either you or maybe some engineer company just can connect the things together and it can just work. Can you do everything you can with the API? No, but the turnkey for us works for probably 90 to 95% of our customers' needs.
Great, thank you. And Noah? Oh, you're on mute. Sorry.
Yeah, sorry. So I touched upon it a little bit. Our customers range anywhere from hospital systems. In Israel, we have HMOs. And we also have third parties that sometimes would like access to granular real-world data in order to develop their drugs and whatnot. And so our platform is supposed to be self-service, and there is a training period, but eventually any clinical professional, not only data scientists or IT, but also clinicians who might not have all the data science background that is needed, or the programming, can go ahead and do those querying and do the discover stage where they dig for insights.
Great.
Let me emphasize a point that Noah made that I think most of the competitors in our synthetic data industry do, which is install on-prem. I have no idea what schema 99% of our customers use, because I don't even see that. It is entirely behind their firewall. That's pretty much industry standard with a few exceptions. Okay,
great. So I have a number of other questions because I'm super curious around this. But one of the things I want to ask about is recognizing that both of you are data science professionals, and the topic of AI is really hot right now. Lots of industries, including healthcare, are trying to figure out what do we do with it. But from your perspective, what are some of the opportunities you see around AI in helping to develop synthetic data? And also importantly, what are some of the potential pitfalls that those of us who aren't data scientists or are using tools like ChatGPT and others should be starting to be aware of, so that we can best utilize synthetic data and AI? So I know it's probably a long answer, but as best you can and briefly help us understand. Chris?
All right, so we're weird in this space in that we're not just a synthetic data company with the same technology, even the same model. We can do all forms of machine learning, basically. So if you say, show me the outliers, the anomalies, the contextual outliers, the inliers, the data density perturbations, and why are they outliers? The same model's doing that. If you're saying, you know what, I've got sparse data here, these things aren't labeled, I would like to impute them, or I'd like to label them, or I want to learn those missing data structures throughout all of that, or tell me what features are driving this prediction. Those of you who are familiar with techniques like SHAP, SHAP is one of the most widely used feature important techniques out there. It's got some big issues. One of which is if your model compresses the data. So if you got, let's say you have race and zip code are two of the features. A model might say, you know what, there's a strong overlap here, so I'm just going to drop race. So you ask it and it tells you, hey, look, I'm just using zip code. I'm not using race at all. Everything's great, except it's not, because the data actually has a lot of those properties in it. So our technology also helps you understand those sorts of things. And there is a lot of pitfalls of, you know, what are the residuals of your AI/ML model? Is it sufficiently calibrated, or is it just hallucinating left and right? So I think, you know, be responsible statistically, use robust methods throughout.
Great. Noah, what kind of cautionary tales can you tell us?
So maybe I'll speak about the opportunities. I think the opportunities nowadays are great in terms of being able to train large models and consuming really large amounts of data in short time, and cost reduction of all of this opportunities.
Great, thank you. And my final question, hopefully we can keep it to like 30 seconds. What are the next steps? What do we want to take away from this event and do as both HL7 as standards developers or others in the industry, regulators, policymakers, and others to help advance the use of and development of synthetic data and testing?
I think it's a couple-fold. One is it is here, we have the capabilities, let's understand it. There's a lot of market education that needs to happen, because, you know, you hear people talking about, well, synthetic data is going to cure everything and you know, slice our bread for us, and people saying it can't be used. There's a lot of nuance there, there's a lot of understanding. So I think it's a combination of education, but also come to some better understandings of what privacy is, what it means, where it's valuable, and how we are thoughtful about it.
Thank you. And Noah?
Now add that I would like to see more collaborative efforts, and we were part of the N3C collaborative, which was a really good experience, and data came in from all over the US and helped promote research for so many organizations and people and individuals. So I'd like to see much more of that.
Thank you. And with that, I want to thank you both for engaging and contributing to this event. We really appreciate it. And we hope you'll be able to stick around with us. And so next up, we have, I'll bring up Dan Vreeman, our Chief Standards Development Officer, and I'll hand over the reins of the baton to him. Thank you, Dan.
Thanks, Viet. Thanks, Chris. And thanks, Noah, as well. You really set the stage with your comments for our last panel here, which we are delighted to jump into, exploring the use of synthetic data for artificial intelligence and machine learning in healthcare. So that's what we're going to focus on. We're going to use a similar format to what you've been seeing. We have three outstanding panelists. We're going to let them give us updates and share their thoughts with us, and then we'll come back around for an open Q&A to close out the session. So I'd encourage you, as things occur to you, whether comments or questions or issues, feel free to enter them into the chat, and/or as a question, if you want to pop that into the Q&A, we'll be coming back to those in the open session at the end. So without further ado, our first speaker in this panel is Sam Schiffman, Principal Architect for Innovation and Strategic Initiatives at Availity. He has worked as a software developer and an architect in several industries. And before it was acquired by Availity, he worked at Diameter Health, where he served as chief architect, helping to build out solutions at scale for fire, COVID-19 surveillance, and numerous other initiatives. We're delighted to have him. Thanks so much, Sam, and the floor is yours. You are muted. Do you want to jump back just a smidge? Yep, I can see your slides, but I can't hear you.
I apologize for that. The wonders of technology.
We got you now. Thanks.
Hi, thank you for that introduction. I think everybody is, or many people are familiar with the story of the elephant that walked into the village of blind people, and one of the people walked up and put their hand on the side of the elephant and found that there was a wall there. Somebody else got hit by the tail and thought that there was a rope there. And still others thought that the tusk was a spear or the trunk was a snake, right? I think this story is interesting because it's really true about healthcare today, right? We have different people who see a patient in different encounters, and they get a very different picture of what the patient looks like. And this gives us a very sort of fragmented vision of care and the care journey. Just one little example that we see. So we did a project where we were doing COVID surveillance for a large state. And we saw over 150 different ways that the COVID test was coded. And this is, real data, in the last couple of years, right? As if that wasn't bad enough, we saw over 40 different ways that negative was coded, right? So that's 6,000 different combinations to tell if somebody had a COVID test and was negative for it. And positive had similar numbers to negative. That kind of computational complexity adds a huge amount of difficulty to solving problems in healthcare. It's multiply that across all the various different domains that we see this for, and we've looked at the data. We see it in all of the domains. However, in synthetic data, generally what we see is we get a pretty coherent picture, right? Codes are generally clean, data is generally complete, and it generally matches the standards that we expect it to. This obviously can cause problems when we want to do projects. So we did a project with Worcester Polytech Institute in Massachusetts, where we were doing decision support around hypertension in pediatrics. And what we really wanted to look at was what was the difference between using clean data and dirty data, right? Now we internally at Availity have a tool that does synthetic data generation, but we do it a little bit differently. We're actually able to generate that dirty data. And this project, we generated that dirty data, and then we ran a cleanup tool on it, and we're able to show just how much better the decision support was looking at that clean data. So how do we do that? Well, we start with the same sort of synthetic data generation where we're looking at statistical models. But then what we do is we run that through a filter where we've actually looked at real data in the real world coming from different EHRs and other systems. And what we do is we then apply that filter to try to create a similar accurate vision, or perhaps you would call it an inaccurate vision, where what we're doing is we're randomizing some of the codes, we drop some of the data, and we add some of the structural flaws that we see in actual data as we've looked through it. So just to really summarize, I think there are some problems with synthetic data, right? It's really real world data is really messy. And if synthetic data isn't messy, then that creates a significant problem in understanding, are we really solving the problem, right? Real data is disjointed, right? Synthetic data, I'll talk a moment about it being longitudinal or not, but it generally is very clean. And synthetic data isn't necessarily longitudinal. What I mean by that is, in general, like I think that we saw that really great presentation on Cynthia the other day, in which they talked about how they really have built out models which can show disease progression. The question is, what about unintended things such as, for example, what if a patient has an amputation, right? Is the model smart enough to know that that patient who got, say, their foot amputated can't have an ingrown toenail later, right? So that kind of errors in the data make it difficult to work with. On the other hand, as we've also heard in this conversation throughout the last days, there's some significant advantages to synthetic data in terms of the risk of privacy, and the ability to manufacture it at volume, and that we can really tailor it to our need. So I think, synthetic data can lead us astray. It can present an inaccurate picture of clean, beautiful healthcare that isn't necessarily true, but we can get work around that. And I think that synthetic data has a huge potential for us to both train systems and validate them. So, thank you.
Great. Thanks so much, Sam. Appreciate you sharing your thoughts with us. Our next speaker is Alex Watson, who is the co-founder and chief product officer at Gretel.ai, focusing on data security and innovation. Before launching or founding Gretel, he launched Harvest.ai, a security startup that leveraged NLP and AI to protect cloud data. And that was acquired by Amazon back in 2016. And then at AWS, he pioneered Macy, one of the company's leading security systems. So we are delighted to have Alex with us, and I will now pass the mic over to you. Alex, please take it away.
Thanks, Dan. I appreciate it. Go ahead and get the screen share going here. Well, nice to meet everyone here. Awesome conversation so far, and hoping to build on some of the discussions we've heard earlier. Today, we're going to talk a little bit about generative AI and machine learning in context of synthetic data. I wanted to start with maybe some of the use cases that we've seen as a company and provide a little bit of insight on where we see things going as well. In the healthcare space, we've got 4 kind of like core use cases that we've seen. Progressing from, I would call it like relatively easy. By easy, I mean like low friction, like easy for a hospital system or a research institution to deploy at scale, going into the more advanced kind of cutting or bleeding edge use cases. So, as has been discussed quite a bit, the promise of private or differentially private with mathematical guarantees synthetic data is really, really promising. And we see that opening up data sharing or starting to open up data sharing in a way that hasn't been possible before. As we start getting to more and more advanced use cases, and we'll cover some of these today, the idea that every data set, everyone has lots of data, but the data you want is always fundamentally limited in some way, right? There's some imbalanced class that you need more examples for, something like that, to support a downstream use case. So another area that we see synthetic data models being very useful is the idea that you can augment a limited data set or a imbalanced class with new examples that will help a model that you might train to recognize a disease or a marker or something like that for a disease to be better at doing that. Other, kind of increasingly difficult, but also really promising things that we see coming up with our customers would be on deployed machine learning applications, how often data drift happens. So how people interact with your application changes. So how do you keep your machine learning models up to date? It's another really promising model for synthetic data. And finally, and this is just incredibly powerful, and we've seen this with kind of the advent of the pre-trained generative models, what if analysis, essentially transfer learning, where you can take something you might know about an existing patient population and apply it to a new population. So you can essentially have a model run experiments for you before you ever need to run them in real life. I'm going to go through these slides pretty quickly. A little bit of background on Gretel. We started in 2020. We built initial synthetic model we built was a language model it supported differentially private training, and it can work for tabular text and time series data sets. Building on some of what Sam was talking about in the previous discussion, that longitudinal component of data sets is such an important thing for synthetic data. It sounds niche at first until you realize how many data sets have a progression or a time component that's very important. It's an area we spend a lot of time on. Our product is really it's an API or SDK. It's not specifically built for healthcare. It is meant to be a platform that any developer or data scientist can use. But we have had a lot of examples, and we're learning quite a bit. I'm really excited to be in this conference, kind of learning about the use cases that you guys are seeing in the industry. Geeking out here a little bit, in the generative AI machine learning space, what types of models do we see today? And what types of modalities? So we'll start with the modalities first. We have been talking about tabular data. So this could be JSON, CSV, FHIR, structured and semi-structured formats. time series data can exist in any of these. And that's where, as Sam was discussing, you might have a patient progressing through time, through the data set, and the need to capture those relationships and be able to replay that in synthetic data. Finally, the natural language component, right? So doctor's notes or things like that that might be mixed into these patient medical records are important. And then the mixed modalities where all of these occur in one data set together. For architectures and technologies that we have seen, we've experimented with and built with, I'm grouping them into several kind of large buckets, but for anyone that's kind of interested in diving a level deeper and kind of understanding what's happening in the research world, I'd say at the most basic level, you have things like VAEs. So these are called variational autoencoders. They are kind of a mix between a probabilistic method and machine learning, kind of combining those two together. So you end up getting results pretty quickly, maybe not the same downstream accuracy you can get from more sophisticated deep learning models. That moves us into GANs, so generative adversarial networks. I think a lot of us are familiar with those. They work really well for highly dimensional data. So we use them with Illumina, for example, to work with genomic data, where you have thousands to 100,000s of columns, and then up to millions of data set or of rows inside of your data. And then finally, and I think an area that everyone's very keen to learn more about right now are the GPT models. So generative pre-trained transformers, language models, traditionally used to train an understanding of natural language, but we've seen the ability to kind of capture knowledge and generate like realistic new examples as being an incredibly powerful step in technology. Other technologies that are worth noting here, differential privacy for those like private guarantees. In the deep learning world, there's an implementation called DPSGD. That's really powerful. It was pioneered by Google, the TensorFlow team. We use that in our products. And also reinforcement learning. So the same types of human feedback that made ChatGPT work so well can be used not just to give you good, like aligned results from models, but then also to ensure that the models that responses you're getting from synthetic data are like diverse and they match kind of your expectations working with the data. I was going to touch on a few use cases that we see here. Apologies, I need to update my slide here. Ignore the text right there. This should have been a plot that we had working with EHR data from a hospital system in the Midwest United States. What they were trying to do is they were trying to train a model to predict how long that a patient that came into the ER, given initial diagnosis, would be there. And the challenge was they wanted to give this to a data science or a development team that wasn't part of the hospital system. So how do you create a private version of that data using synthetics, essentially create an artificial version that has the same insights? They could provide to that team to do the application development, the model training, things like that, get just as good of answers as you would get on real world data without actually sending over real world patient records. So that was one of the early use cases that we had at Gretel. We see quite a bit of that still today. Oh, here is the intended slide. So here you can see this is an actual output from, I believe, an Epic EHR system. You can see that the number of stay minutes that was there. You have doctor notes, so you have this kind of mixed modality with text. So exciting stuff. Ended up working really well for the hospital. Second use case to cover too was this actually came up with the University of California, Irvine. And this was early days for Gretel, where they said, hey, if we can create a synthetic version of a data set, can we boost certain attributes in the data? And they called out a heart disease detection data set. It's an open source data set. It's very popular on a machine learning platform called Kaggle. And they said, can we boost female records, which is imbalanced in this data set? And what would that do to overall predictions? And what they were able to show was by essentially addressing that representation bias, they were able to improve heart disease detection, not just across the entire, or not just across like female patients, as you can see here on these different algorithms, but actually across the entire data set. So it was an exciting outcome there. Where is synthetic data going? And so this is one that we're really excited about. We've been working to build essentially an LLM that's built to work with data. So we've trained it on about 500 billion tokens. That's the same size, for example, that Meta has been fine-tuning their Llama models on to do code generation. And we are teaching it essentially to understand data sets and to be able to introduce new columns, new features or things like that, or even clean data. So we're really excited about the possibilities here. When it comes to generating more records, for example, or sometimes you just don't even have access to data. Like how many startups, how many ideas have even people here had where you want to get started, you have an idea, you want to test it, you just don't have access to data to do it. I think one of the promise that we're going to see of upcoming LLMs that can work with data is they can build a realistic data set given just a schema or a natural language description similar to what Cynthia has done without requiring you to write any code yourself. So exciting possibility. And last thing to touch on today was talking about some of the challenges that we see around LLMs. It starts with privacy. And I think there's some really like promising technologies that are out there to address that. But LLMs, the promise of them to be able to query your patient medical records or your healthcare data is really powerful. But LLMs do not understand privacy. So whereas you might, ask one question like, where is diabetes spiking in the United States and get a zip code back, which is really powerful. You could ask the same LLM, bring back any patients who have a birthday of this date or something like that. So that's why it's so important that privacy is built into the data that these LLMs are interacting with. Other parts, I think maybe one of the hottest areas that we see in research right now is around alignment and trustworthiness of LLMs. So how do you make sure that when you ask an LLM a question that it's really confident in its answer and it's not kind of making up the best answer it can think of? So that's a really important part. And also, how do we make sure that the results we get back from the LLM are aligned with our own values and not just the training data that it has? So that's when we talk about reinforcement learning, that's one of the areas that is really promising to address there. And finally, on knowledge update and retrieval. Training LLMs is super cost. It's an expensive, computationally expensive process. There are lots of techniques that are coming out right now to allow you to update LLMs with new information. We're just starting to learn or really understand what the effects are, where you have one option is train an LLM from scratch on your data each time. Sounds great, but it can cost millions of dollars in training. Fine-tuning it, so updating an LLM's weight based on new data or data you might have inside your business. And then finally, information retrieval or augmentation methods, where essentially you can very quickly search for documents inside your business and use that or data to augment, essentially, very quickly prompt a model with the information it needs to come up with an answer. So these are all really big items today. Happy to dive in on any of the individual topics. And that's it. Back to you, Dan.
All right. Thank you so much, Alex. That was great. Really interesting coverage of a lot of different things. And I hope folks are thinking about questions to ask this esteemed group. Next up, we've got Angelo Castrulis, who is a accomplished author, inventor, entrepreneur, and health IT expert. His research as a member of the Harvard Data Systems Lab was dedicated to harnessing AI's potential to develop self-tuning data systems. He also co-hosts the Counting Sand podcast, which engages in discussions on health IT, computer science, and AI. So please join me in welcoming Angelo to the podium. Angelo, floor is yours.
All right, thank you, Dan. So I think when I think about myself, and this is going to color the discussion a little bit, when I think about myself, I think of myself as part researcher. That's part of my DNA, I think, and part implementer, because that's where I've come from. And I've spent the last several years focusing on decision support, CQL execution, both trying to figure out how to execute CQL at scale on big data, but also kind of the AI side of my academic side, trying to kind of find a way through that. So I think that we'll talk a little bit about what's going on there. All of the previous discussions, I think, have touched on this, so I won't spend a lot of time. AI can work really, really well with unstructured data. Computational systems like rules, which is why I think this perspective is important. CQL and other rules need structured data. And so you have a bit of a mismatch, but you need both of them. And just to kind of illustrate like why this is super important, we all know that COVID was a topic that was very heavily researched. 92% of the submissions of papers in 2020 were all about COVID-19, consumed 4% of the world's output of research. And that research eventually leads itself into guidelines, which then make clinical rules, which then we could execute in some way. So they kind of find their way downstream. But that presents a problem because they kind of bottleneck, and that's actually hard to get that much data out there. So when we think about these two aspects, we've got AI, which encodes knowledge by trying to find patterns in data. And then we have clinical rules, which are manifestations of guidelines, which are the same thing. We've tried to find knowledge by finding patterns in data. We then have experts analyze it, we peer review it, and then we come to a consensus and publish. And that's a little bit easier to understand, even though at the underlying all of this, we have the same kind of approach as AI does. The thing that AI is critically missing, though, is that you don't have the expert who can then have this peer reviewed, and it makes it highly explainable. Now, going to rules, just kind of one level deeper, when we want to execute rules like CQL or some other rule language you might have, we need data to be able to test it. And synthetic data is ubiquitous. We all kind of make our own data, especially as we're authoring these rules. And so it's a good candidate to generate it. Alex talked about some really great techniques for doing that. And so have many of the other sessions. But I think something Sam touched on is super important. And that is that dirty data actually is critically important to rules, because we either have to find a way to work around them in the rules, we encode it inside there somewhere to trap this stuff and deal with it, or we find a way to kind of pre-clean it before it goes into the rule. Now, there's some very interesting research being done in scoring and data quality, so that we could say, well, along with your rule, wouldn't it be interesting if we could say, this rule, here's your answer to this guideline. However, low confidence because the data is pretty dirty. Or here's an answer, and the answer is pretty confident because the data is pretty clean, and we're fairly certain of that. By the way, that's also something that's missing in AI. But I think that that's the journey is what kind of led me to look at AI a little bit differently. Scoring data, I mean, that AI fits naturally into that. Scoring the data as you execute the rule could be done with AI. But there's I think some other interesting aspects. One question that typically comes up is, why can't we just statistically permute the data? For example, get a match to the rule and a non-match, and then permute them and put them into the ruling. You get dirty data that way. And I was on the same camp. I was very tempted to do that. And what I found is it's just not that easy. This is a diabetes rule. It is not particularly complicated, but it's a pretty large tree. So if you permute data, which branches are you testing, right? Do you even know if you're testing it at some point? It becomes just a really, really hard problem. And when we want to test rules, we're wanting to actually make sure that the rule works really, really well. Modern AI approaches, though, and Alex talked about GPT, and of course, we're all super interested in that. But one of the things that I think GPT showed was that there is some innovation here. When you take a bunch of different models and you put them together in novel ways, they have a very different predictive profile. And it's actually shockingly good. So what we do is we can assemble models that do very many different things. They can do NLM, they might be neural networks, but if you put them together in a certain way, you can now do new and interesting things, generatively making other technology. But they're still missing that key ingredient, and that is the rules structure. We're just making statistical variations of the data. What if we could encode the rule structure into the AI so that the AI becomes aware of the rules aspects of what it's trying to accomplish? Effectively, we would be encoding the guideline into the AI so that it's producing synthetic patients that might meet or not meet the guideline, but are aware of the structural aspects of the guideline. And one way to do that, at least some of the way we've been kind of leading our research, is to say, what if we inserted layers? They could be in different positions in the stack, or when I say layer, it could be something that's another model outside, but why not have something like that that kind of understands the rule structure, and now you can produce much more interesting in results that will help you actually exercise a rule. But there is something else that's kind of like a byproduct of this. What if, though, that model, and a generative model is really interesting, because what if I could inject this into the authoring process? I could actually get feedback, a feedback loop with the individuals, informaticists making the rule, so that they can then start building the rule themselves. And now there's this interplay between the AI and the rule itself. You might change the rule based on some feedback. Oh, I want to trap this dirtiness in the rule, or that doesn't meet the logic branch that I wanted, or hey, there's other ways to represent this disease and I should catch that. You get some very interesting and different approaches to being able to author, which I think are compelling. But there's something else, and I call that the expert AI. There's something else here, which I think is this is really, really new. I think nobody's doing this that I'm aware of. But there's another thought here, and that is, what if we could take the output of the rule? So if we have a guideline that's being executed, and say it's a HEDIS measure, and we feed that back into the AI. So now the AI isn't just aware of the structural aspects of the rule and the guideline, and aware of the statistical aspects of the population, but it's also aware of the results of these executions of the rules. Now you have something a little bit different. It's almost like you have a higher order abstraction of clinical knowledge built into the model. Okay, so what could that do for us? Well, outside of synthetic data, a byproduct of this could be that we use those models to become a framework to generate other models. For example, imagine, and Jason had a really great demo yesterday of Cynthia, where he showed the process of mapping a disease's progression. That requires an expert to do the work of mapping the disease progression and making sure it's done right. However, inside the clinical guideline and inside of the rule, there already exists a mapping encoded just structurally of what that guideline is looking for. And so what would be really interesting is now on the fly, you're able to produce models that are aware of the different guidelines of whatever rule they're given. They reconfigure themselves because they're retrained on them. And so now you may have the ability to generate new kinds of models. And where that's really interesting is who's driving the model. Ultimately, it's the rule author drove the model. That means that the models are indirectly created by experts. So now you kind of have this really interesting loop of a model being created by a person who can now quantifiably explain what the rule does, because a rule inherently has some explainability to it, that is then used to explain a model that is derived from that. So there's some particularly interesting research areas that we could go down here. They're open topics, but they open the door for some really, really interesting stuff. So where are we going? I mean, the research is definitely ongoing. There's a lot here, and some of this is highly theoretical. But there is a clear absence in the exploration of explainability, just in general in expert systems. We've been trying to understand this for a really long time, but certainly not with the integration of AI and expert systems in this interplay. Could we use it even maybe to shorten the feedback loop of not just rule creation, but guidelines? And that is interesting because guidelines take quite a long time to make, which then we get the rules, and then the rules get executed. And then we learn that there are issues with the guideline. So we don't have a really great way right now to get that feedback loop. So where can we go from here? Stay tuned for our findings. We'll look at that. But I encourage anyone who's interested in it to start looking at these kinds of areas, because it is really a green field. There's not much being done with clinical quality language and rules and explainable AI. If you want to talk about it, I'd love to talk about it on the podcast. But also, GPT has opened a door where there open sourced and the models are kind of out there and we can start playing with them. And maybe there's an opportunity for us, if we can move this a little further along in research, that we could, as a community, start taking some of the well-known guidelines and maybe even sharing those, having architectures and layers that we can add to other models and create our own ensembles that have that kind of approach to it, so that we can do some different things in healthcare. And that is the last slide of my talk.
Great. Thanks so much, Angelo. And let me welcome back all of our panelists now. We're going to spend some time in Q&A and discussion. We've had a few things pop up in the Q&A box in the chat, so I'll try to work through these. Maybe I'll start with one. I think this one may be directed a little bit more towards Alex, but it says there was an article in the Wall Street Journal around the beginning of the month mentioning collaboration between Illumina and Gretel. It was stated that Illumina wasn't going to pursue synthetic data further. Any idea why? And I might add, might there be any lessons for this audience in their consideration and use of synthetic data that we might take away? So what are your thoughts there?
That's a good question. So I was surprised we weren't reached out to for that article. So I reached out to the author after it to offer to comment, and it wasn't really clear where that came from Illumina either. We've been working with their essentially their emerging technologies team, and the goal was saying, could we use synthetic data to create essentially synthesized genomic data and recreate the results of popular research papers? And so what we've done so far is we've demonstrated that. We've also applied for access to the UK Biobank, which we were recently granted, essentially to start working with a kind of human level genome data. There has been, as I think probably a lot of people on the phone call are aware, a lot of stuff going on at Illumina that is outside of our control, but that project is still moving forward. So we're excited to work with them.
Great. Thanks so much. Here's a question, probably I think all of you might be able to chime in on from Farhana in the chat here. One of the advantages of AI in healthcare is to provide insights that experts are still unaware of. So with the feedback loop, are you baking current knowledge into the process that actually makes it harder to discover such unknown trends? Any thoughts or comments about that?
Yeah, I can speak to that one. I think that's one that's super interesting to me. I think that's very true. That is one of the things that why we need, in the first early slides we talked about, that's how the two kind of work independently in the same way. AI is trying to do the same thing that researchers are trying to do. I think that there is some room, though, for some novel approaches where you have the same encoded knowledge and you're effectively testing it, or you're effectively deriving other things from it. But I do agree that this should not replace the ability for it to detect new things that have not been seen. I think that's critical too.
Yeah, I mean, I think there's some really interesting things around the world of complexity, and as the model gets more and more complex, it's able to do things which are very interesting. I also think we do have to think about where AI and particularly generative can be useful and can't be useful, and make sure that we're not taking it to places where so let me rephrase that. I think we have to understand what the value of the use cases that we're looking at are before we bring generative into them. So for example, if we talk about using generative AI to write a clinical note on behalf of a physician, right, then we've removed not just the amount of time he took to write that note, but we've also removed the subtle context that he's bringing to writing that note, and replaced it with a generic, and that could have adverse effects. So I think it's a really good thing to think about, that you don't just leap in.
Great. So another question here. We've heard about the importance and quality of training data being used to train AI models in various techniques, supervised ML, unsupervised reinforcement, et cetera. Maybe could you expound a little bit on how each of you is going about creating that training data, or what are some of like the key things you might look for in that in the characteristics of the training data. Any comments from the panelists?
Well, I would say one of the things is definitely the messiness. Definitely we're thinking about how does the messiness look like real world messiness, and not just, not just adding random noise, but saying, okay, we see that, for example, Epic always drops this particular field, or, or this percentage of doctors is going to enter this as free text rather than as picking a code, right? So that you're really ending up with data that's representative.
I think that's a great point. Maybe something that we've seen is the diversity in training data is still so important. In the limited experience, like going back to the Illumina example that we had before, where you have kind of national level efforts that are pushing forward, like genome sharing, right? Like UK Biobank, for example. What that results in is the world kind of getting access to still a very demographically centered data set, right? It is people that live within the UK. So I think one of the things that we look for, both in training, but then really looking for in the output of the model, is to not just learn off a very limited training set that it's given, right? Give it the best trainings that you can, and then also ensure the output of the model is as diverse and kind of aligned with your expectations as you can.
Yeah, and one thing I'll add too is we thought originally that generating synthetic data could be done with something like Cynthia. Then you can just encode your own rule. Now, of course, when you're testing hundreds of rules, that becomes onerous. And then you think, well, we could just traverse the rule itself and generate all the permutations to go down every logic branch. And then you end up getting nonsensical data just to test the rule, which isn't really then a real test. So I think that that's what makes this really interesting, using AI to do this, is because AI will give you data that looks more realistic than just generating with a heuristic, going down logic trees. It just doesn't give you something that's very usable, but it does give you something that tests not correctness of the rule, but just does it break? And that isn't necessarily what we're looking for.
Mm-hmm. Yeah. So I'd like to ask each of you a question that I get asked a lot, which is, whether we're talking about synthetic data or we're talking about data from clinical institutions, quote, real data in some way or another, we're certainly moving very quickly towards like AI everywhere, sort of pervasive, applications and so forth. Are we still going to need data standards, to be able to define the structure and content of health information? Won't these AI models just sort of be able to figure it all out for us? Any thoughts to that kind of a question?
I think the irony of all that's happened around machine learning and training large language models, it started with train on everything, like crawl the entire internet and train everything to get the most knowledgeable model possible, right? But if you look at what's happening now, it's a swinging the pendulum back towards much more like research-oriented data sets, right? Where you have really high quality data. So I think one of the advantage of a standard is that it does promote much higher quality, like more kind of curated data. And then also interoperability of systems. Just because a language model might be able to rip through something and understand a really weird format doesn't mean that like the humans can. So having a standard format makes it so much easier to share data between organizations and institutions.
Yeah, I mean, I think that's kind of the key there, is it's a matter of bandwidth, right? If we had infinite bandwidth, if you could run the best LLM and trained off of every data and run it instantaneously all the time, possibly you could not need standards. But what standards really bring to us is a context around the data that makes it easy to work with, right? And that lets us lower the bandwidth that we need. So for example, that COVID-19 test, right? If we bring that 6,000 different combinations down to one combination, you need a lot less bandwidth to figure out what you want to do.
Yeah, and I would add one more thing, and that is, as long as you never need to semantically interoperate anything, you don't need to understand its output, then yeah, you don't need a standard. but that's something that the whole point of these models is we have to do something with them, and we have to give them to someone else to be able to understand them. So you're going to need a standard to be able to accomplish that.
Great. Thanks for that. So as we come to a close, I'll just ask each of you to share a few thoughts on what you might see as next steps here for the community that's gathered here, or the industry at large. Where might we go as far as some next steps? And I'll start, we'll just go through maybe the order that we spoke in. So maybe over to you, Sam, first.
Sure. So I think that there are many pieces that we could be talking about here in terms of quality of synthetic data and how messy is it and where are we going with AI. I think the really important piece is to focus down on the fact that AI is here, and we need to think about how we're going to start responsibly representing it and the results of it in standards. And so, I think the next steps for HL7 are really to take it seriously, to think about, as data is coming out of an AI, how does it appear in the standards? How do we know the provenance correctly? And how do we make it useful without losing the data, right? So, how do we prepare it in such a way that it can be available in the future?
Thanks. Alex, thoughts from you?
Yeah, I think short-term wish list would be building some standards around privacy that made data like interoperable or shareable between organizations. I think would be really neat. We have these like formal mathematical guarantees, and then you have de-identification. You've got everything in between. So I think that would be really neat. Also, I think maybe one of the hottest topics we've touched on a little bit too is like regulation. It's coming, right? Like with technology advancing this fast, it's going to be used. It's going to be used for different use cases, and I think maybe staying in front of it and talking about like how do we ensure that these models that are being used increasingly to make healthcare decisions or care decisions or things like that are tested and kind of meet the standards. So I think that'd be a really neat kind of next step to dive in on.
Great, thanks, Angelo. Thoughts from you?
Yeah, I think with synthetic data, I've never met anyone who didn't agree that we needed it. We all are always asking for it. Universally, we all say, yeah, I'd love to have some. Do you know where I can get some? And I think that that's the one thing that I would like to see a little bit more of, more appetite to be able to have case studies and pilot projects that can research this a little bit more. I know it's very hard to make a compelling case to finance synthetic data. Everyone knows we need it, but then they go, what's the business ROI? So it becomes really hard. So I'd like to see that. I think along with that would be accessibility. Once those pilot projects do that, if there was a way that we could share this so that we could, as a community, use this, understand it, and use the synthetic data, I think that would be my wish list.
Wow, that's great. Well, thank you all for sharing. You've given us some ideas to percolate on and to brainstorm how we might move forward on. We've reached the end of our time here for this session, and actually the close of our time together. So with that, I'd like to pass the mic over to my colleague Viet, who's going to share a few closing remarks. Thank you.
Thanks, Dan. Let me bring up my slides here and try to gather information over the course of the event so that we could kind of share it back with you. So let me confirm that we have my slide up. Yeah. Great. I also want to acknowledge that I'm sorry, Michelle, you had your hand up. If you could put your question in the chat or in the Q&A, we'll try to have the last session's participants try to answer. We just unfortunately have run out of time, and we want to make sure we do a good wrap up. Thank you. So this has been an amazing day and a half. I know I've learned a lot. We've had a diverse set of presenters and themes and topics. We hope that you have learned a lot, enjoyed the presentations, and have been able to participate. But I just want to highlight some what we looked at, some of the notes from the sessions over the last day and a half, and some of the themes that have come up. And feel free to add what you thought were also some major themes if I missed it. I know privacy has come up quite a bit. We've tried to address it in multiple sessions with the different speakers. How do we validate the data that's created, synthetic data, to both, demographics as well as avoiding, a bias and addressing bias. I think it's important that with this diverse community that we're trying to identify opportunities to make these tools and data more approachable and accessible for this diverse audience and potentially folks who aren't technical. So, I often say that interoperability in data in any of these projects is a team sport. So how do we have subject matter expertise who aren't technically engaged? How can they help a team look at the data and make sure that it's appropriate? We've talked a lot about fit for purpose data, fit for purpose being both broad data as well as specific to particular diseases or use cases, as well as when we look at testing, the synthetic data from Cynthia may have a really good relevance for a number of areas. And then how do we make that data more specific through different modules and use them for testing, recognizing that they're very kind of programmatic and that there are opportunities to use synthetic data by AI and other approaches to make it looking more like real world data. I think we've had great discussions around AI and opportunities, especially in that last session, around how we can support development of synthetic data. But also, I think there's a lot of education left to do. AI and data scientists have, in my opinion, have been focused on kind of areas where there's lots of funding, e-commerce and other areas, and that we have this great group of presenters who are working in healthcare, but certainly I think there are opportunities to grow that expertise, but that requires us to kind of develop our understanding of AI and data science so that we can better have those conversations between subject matter experts and the folks who are data analysts and data scientists. So if there are other topics that you think we should try to capture during these, please add them to the chart. So the next few slides, I think I have 4 of them. We tried to gather and sometimes may repeat some of the responses from our panelists around what they see are the challenges and next steps that we can take from this meeting and decide how can we further advance the conversation and to address some of these areas. So, excuse me, if you have your own thoughts, please make sure that you add this to the chat, and we'll add these to our notes as well. So I think, again, lots of opportunities for machine learning to make sure that the synthetic data gets better. Opportunities to engage in ChatGPT, looking at structured data with large language models. We need more clinical informaticists. In my view, clinical informaticists provide a kind of a bridge between the clinicians, the subject matter experts, and the technical folks, recognizing there are different kinds of informaticists. That just happens to be the kind I try to do. But we need them to help us to develop these more data sets. We need improved methods for validating these synthetic data sets. Certainly, some of our presenters showed their approach. We need to manage the techniques in assessing these large data sets and looking at issues around fairness and metrics, as well as ultimately maybe developing standard techniques with these synthetic data so we can use them more broadly and make them available to other non-technical folks. You need to build trust in synthetic data. I think this event was hoping to move forward on that, to engage you all, and hopefully have you go back to your organizations and talk about what you learned here, so that we can start to build trust. Expand on information gain analysis. I'm going to admit I'm not sure exactly what that means, but we'll get back to the presenters on that one and evaluate that. I think a library of training data sets would probably be really great. And I think that's probably some opportunities for both the researchers and others to help provide those. Again, developing specific use cases and make them realistic for the clinicians so that they can, I always say it has to pass the sniff test when we're looking at data as clinicians. Is it really representative of the kind of patients and individuals we see? Creating an AI plugin to help students create synthetic data. I think that's a great idea. So hopefully somebody's willing to take up that mantle. And of course, stressing the education needs in order to be able to have those conversations within our community around synthetic data. And lastly, around Cynthia, I was wowed actually by the number of conversation discussions around Cynthia. I think the folks at MITRE have done a great job kind of establishing Cynthia and its core functionality. But really, again, I think Jay Walanowski mentioned it's still kind of relying on contributions from the community. So I think there's an opportunity there for all of us to go back, look at that Cynthia GitHub and the work they've done, and look at opportunities to support that community by expanding the models that are there into models that are useful to you all. And with that, looking at ways we can validate the structure and semantics around that. And again, education is key. Excuse me. And more, of course, more collaborative efforts. That's certainly a role for HL7 to help bridge the different communities, at least for the standards, but also others in working with synthetic data. And then, of course, there are lots of interesting opportunities for research and lots of areas that have been uncharted. There are additional comments from the last group. The focus on AI is here. We have to be responsibly representing it. We need to be able to make standards, develop standards to make data de-identifiable. So I'm reading from my notes here. We need to stay ahead of regulations, because certainly at some point there's going to be a potentially regulatory initiatives to try to help the industry. And I think we all agree we need more of this, more use of synthetic data, and expanding the understanding of the value and importance of using this data in both our standards testing and improving our data standards, as well as working towards when we develop research and production applications and to improve their value and quality. So finally, we really want you to continue to engage with us. This is the beginning of an ongoing conversation with our community. So we invite you to check us out at hl7.org, where you'll find information about our education, our events, and in particular, information about our upcoming Connectathon and work group meeting. I'll elaborate on that a little bit more. We have a Confluence site where we have a plethora of information about our various work groups, our processes, our FIRE accelerator. So if you want to start to engage with us, go ahead and look at Confluence. You can set up a free account so you can look at the information and join us in our standards process. You can find out about different work groups and projects. If you're a developer, an implementer, we have chat.fire.org, which is free to join. It's a really diverse and huge, I think there are maybe 10,000 registrants of developers and standards developers as well, across the world, around the world, helping to better understand how to implement FIRE, as well as having conversations like there's a stream around machine learning and data analytics. So invite you to join those conversations in chat.fire.org. I want to highlight that in about a week, we have our 3 times a year working group meeting, including a Connectathon. The Connectathon is over the weekend, and the 9th and 10th. I think a number of our presenters mentioned that they'll be leading tracks around quality of metrics and machine learning. And we have about, I think, 43 different tracks. So you can find out more in Confluence. We have a FIRE page that has our Connectathon and our different tracks. And then we have a week's worth, or at least 5 working days worth of our working group meetings, where our various HL7 work groups have face-to-face discussions around the standards that we're developing and maturing. And I would like to invite you all to participate and watch our Monday plenary session. September, we typically have these plenaries where we highlight a particular topic. This September, very conveniently, is around AI. And really, we're bringing in some industry leaders to help us better understand some of the needs and some of the current activities around AI in healthcare, with the goal of helping HL7 and our member community start to understand what is our role in developing interoperability standards around AI. I think there's a diverse set of perspectives and views. And so we want to really start to have those conversations within HL7 so that we can start to anticipate where our opportunity to contribute to developing standards can begin. So we often get questions around events slides. So we will be sending you a future email around getting those slides once we have consent from our presenters, and as well, Crystal just put into the chat, so please take a look at chat. We have a post-event survey. These event surveys are really important to us. We need to get your feedback on whether the topics and the range of topics met your needs and expectations, where we could have had additional topics, and feedback you can provide around the various sessions. Certainly, we're happy to take that feedback via email as well. So please do the survey and be on the lookout for future emails around the recordings and the slides. So with that, I want to thank all of you for being here with us for the event, and especially for the presenters. Your contributions have been really immeasurable in helping us advance our understanding and the knowledge of what's happening around synthetic data. And I want to particularly also thank the Crystal Callum, that coordinated this event, and the presenters have met her during the preps, and she's been behind the scenes, as well as our HL7 staff who've been behind the scenes with logistics and making this event possible. So we want to thank you all again for your participation, your engagement, and we look forward to having you at a future HL7 event, and maybe even at the Connectathon. So if you come to the Connectathon, a working group meeting, please come up and say hi and give us your feedback then too. So thank you again, and we look forward to seeing you in a future meeting.